Hi, I'm single-minded Ryan. I'm here to help you learn how to make a 3D Unity game with some amazing assets. First, I want to make you really feel like you are creating a professional game all by yourself from the very beginning. So I put a lot of effort to create an asset package for you. From high-quality characters, animations, environment prefabs you can use to build up your own levels, to VFX and post-process settings that will make sure your game looks amazing. In this course, you'll learn how to write C# code to create a 3D action game step by step. Specifically, you'll learn how to create the player's basic movements based on state pattern, how to control animations and use animation events, how to set up state-based enemy AI behavior with Unity Snap Mesh system, how to use VFX prefabs, create pickups, how to make a health and damage system, and an open door system, how to write the overall gameplay logic, debug your game visually, and create fully functional main menu UI and game UI systems. Please join me on this amazing game development journey. When you finish this course, you'll understand everything you need to know to start making your own 3D action game. Thank you for taking this course. I look forward to seeing all the amazing games you'll make. Hello and welcome. In this lecture, we are going to be installing the Unity Hub and Unity 2021. First, let's go to unity.com/download. Click on the blue button that says Download for Windows. Then, install the Unity Hub when the setup program is downloaded. Open the Unity Hub. Before we start to install Unity, you are going to need to create a new Unity ID or sign in if you've got one. When Unity asks us for the license, we go for a personal license. But don't forget to read the terms to make sure you are eligible to use Unity personal license. Now, let's install Unity. Select Installs on the right side, then click the Install Editor button in the upper right corner. Here, we want to select the latest version of Unity 2021, which is 2021.3.13f1 at the moment. I personally don't recommend any versions of Unity 2022 right now due to some instabilities. Now click Install and leave everything as default. It might take a while for the installation process. When it's finished, just leave the Unity Hub aside, because we need to install Visual Studio Code in the next lecture before using Unity. In this tutorial, we are going to be using Visual Studio Code as our script editor. If you've already had another script editor installed and you are happy using it, you can skip this section. But in general, I think it's a good idea that we use the same script editor, so we're all on the same page. Let's go to code.visualstudio.com and click Download for Windows. When it's downloaded, install it at the default location. Unity needs the path of this folder to connect to Visual Studio Code later on. So let's select the path and Ctrl+C to copy it. I'll leave everything else as default. When Visual Studio Code is installed, don't launch it right away, because we also need to make sure our .NET Core SDK is installed and up to date. Let's go to .net.microsoft.com/download. Download the SDK and install it. Now, let's open Visual Studio Code and install two extensions. Go to Extensions, search and install C# extension. Next, search and install Unity Code Snippets extension. When these two extensions are installed, please close Visual Studio Code for now. Let's create a new Unity project with Unity 2021. Click Projects on the left side. Hit New Project. First, we need to select the editor version from the drop-down. You can go with any version of Unity 2021. I recommend Unity 2021.3 LTS. Please do not use any version of Unity 2022 at this moment. Otherwise, you may end up with some bugs right off the bat. Next, select the 3D Core template. Then, uncheck Enable Version Control box. Give it a name and set the location. Then hit Create. Before we go on to the next section, I want to make a quick notice. Even though we just created a new project with Unity 2021.3 LTS, I actually recorded most of this tutorial with Unity 2021.1. I believe it should be perfectly okay to use Unity 2021.3 LTS with this tutorial, even though you'll notice some minor UI differences between 2021.1 and 2021.3 along the way. In general, I don't think those would cause any problems for you, but I will attach a PDF file regarding the differences between the two versions in the resource section of this lecture in case you want to check. To make Unity look better, we can switch the light theme to dark. Go to Edit, Preferences, General, Editor Theme, and select Dark from the drop-down. Now let's set Visual Studio Code as the script editor. Go to Edit, Preferences, External Tools, and External Script Editor. If you see Visual Studio Code here, that's great. Just select it. If you don't, select Browse, paste the path we just copied, and select code.exe. Now we've set Visual Studio Code as our script editor. Let's test if our extensions work. Right-click to create a script. Name it Test and double-click it to open Visual Studio Code. When you open a script in your project for the first time, you need to select the .sln file here so that Visual Studio Code knows how to organize the project properly. You should also check if Visual Studio Code can detect the functions in the script. Let's type out game. If game object shows up, we know the extensions are working. Now we can close Visual Studio Code, go back to Unity and delete the test script. Before we get started, there is a very important thing that we need to do. Let's go to Edit, Project Settings. In the Player section, we need to set color space to linear. Click Change to Linear to proceed. If you don't do this, you'll be using gamma color space. Your project is going to look completely different, and let's say that is not very good. After setting the color space to linear, we can close the window and import the game asset package that I have put a lot of time and effort into making for you. Please download the game asset package from the resources section of this lecture first. Then, right-click on the assets folder, import package, custom package. Find and select the downloaded Unity package file on your disk and click Open. Then you'll see this warning. Please make sure that you are using an empty project. Do not import the package into an existing project or any of your personal projects. Doing so could override your project settings and potentially ruin everything. Hit the Import button here to start the importing process. When the process is finished, go to the Game Asset folder, which is called Project Little Adventure, and open the Overview scene. Don't panic if you see this pink screen. Pink is the color that Unity uses to show you that the materials are not compiled yet. This is happening because we don't have URI installed yet. I'll show you how to fix this in the next lecture. Let's fix our pink problem first. Go to Window and select Package Manager. Go to the drop-down in the upper left corner and select Unity Registry. Scroll all the way down until we find Universal RP. Select it, then click the Install button in the lower right corner. Close the window when the installation process is complete. I know you are probably wondering why everything is still pink. This is because we have not assigned the render pipeline asset file yet. Let's head to Project Setting, Graphics. Click this little circle and select Universal RP High Quality. This is a render pipeline pre-made by Unity, but I've already twisted a few settings to make the graphics look better. For now, you don't need to know too much about this asset. Let's just close this window. Now we can see everything finally looks right. We need 3 packages for this tutorial, which are Cinemachine, Visual Effect Graph, and Progrades. Now let's add them to our project. Go to Window and select Package Manager. Make sure Unity registration is selected. Next, scroll down and find Visual Effect Graph in the list. Select it and hit the Install button. Next, find Cinemachine in the list and click on it. Then hit the Install button down the lower right corner. Our last package is Progrades. You might not be able to find it in the list because it's still experimental at the moment, so we need to add it manually. Go to the plus icon in the upper right corner. Select Add Package from Git URL and type in com.unity.progrades. Hit Add and wait for a few seconds. There you go. Now we can close the window and hit the play button to check the overview scene. In this lecture, we're going to create our game scene and set up a level in the scene. We're going to start by going to File, New Scene. We're going to choose the empty scene template rather than the basic scene template, because the basic scene template comes with too many things that we don't need. You're going to see a black screen like this that says no cameras rendering. This is completely alright because the empty scene comes with nothing, not even a camera. Now let's save the scene. Create a folder under the root folder and name it Game. Know that all the things we are going to create in this tutorial are going to be stored in this Game folder. Now press Ctrl S to save the scene. Go to the Game folder. Let's name the scene Game Scene. Then click Save. Next, let's head to the prefab folder. Under the project Little Adventure folder, we can find a prefab called Game Level. Drag it into the hierarchy. This prefab is a level I prepared for you. It contains everything we need for the game level, such as the level layout, particle effect, lights, colliders, post-processing volume, etc. But of course, you can build your own level from scratch if you want later on. You can find all the assets you need in the project Little Adventure folder. But for now, I recommend you just follow me and use this game level prefab. Before we move on, let's make sure the position of the game level prefab is 0, 0, 0. You can check it out in the transform component in the inspector. If it's not, you can click the 3-dot button at the upper right corner, then select Reset. Next, we're going to create a camera by right-clicking in the hierarchy and selecting Camera. First, let's set the camera's tag to main camera. Then active post-processing under rendering section. Let's move the camera a little bit so that we can see the level better. You can just use the position I have here. Before we move on to the next lecture, I want to talk a little bit about how to make the game look better in the game view. The default resolution scaling of the game view is 100%, so everything looks a little blurry. If you have a nice graphics card, I recommend using a higher resolution. You can do it by clicking Free Aspect at the top of the game view, then selecting Full HD or higher. Now we got a higher resolution in game view. Maybe you can't see the change in this video, but please give it a try for yourself. Keep in mind that a higher resolution will have a huge performance impact on your graphics card. So if the game runs below 60 FPS in the game view, it's better to just go back and stick to the free aspect option. In this lecture, we're going to create our player game object. Right-click in the hierarchy, select Create Empty. Let's name it Player. We're going to reset the game object's position by clicking the three-dot button at the upper right corner of the transform component and selecting Reset. Go to Project Little Adventure, Mesh Asset, Character, Main Character. Drag Little Adventure ND mesh file onto the player game object. Rename the mesh game object to Visual. Here we can see an animator component is automatically added to the visual when we drag it into the scene, since a visual contains a character model and skeleton. In most cases, this component comes in handy, but it is not what we want for this tutorial. Let me explain why. We're going to be sending a lot of messages from the animator controller to our player game object throughout this tutorial. In Unity, these messages can only be received by the same game object that the center animator controller is attached to. You see, our player and visual are two different game objects. So if we send a message from the visual, the player game object will never receive it. This is why this animator controller in visual won't work for us. Let's remove it from the visual game object. Now we're going to add some lights to lit up our player. It seems like these lights don't make any difference. This is because they're set to only affect objects on the player level. Let's expand our visual game object. Select Little Adventure ND Mesh and change its layer to player. Now with the lights working correctly, we finished setting up our player game object. In this lecture, we're going to be setting up a virtual camera that follows our player. Right-click in the hierarchy, select Scene Machine, then select Virtual Camera. Now we got a new game object with a strange name. This is the default name Unity gives whenever you create a virtual camera. Drag in our game object to the Follow slot and Look at slot. Change body type from transposer to framing transposer. Set the damping XYZ all to 0. Set camera distance to 32. Change aim type from composer to none. Let's go back up to the transform component. Set the x-axis of rotation to 45 and y-axis to -45. In our game, the camera looks like an orthographic camera. But actually, we're going to be using a perspective camera to mimic the look of an orthographic camera. Because some of the VFX doesn't work with the actual orthographic camera. Let's set up the orthographic camera look. Set vertical FOV under lens to 25, near clip plane to 10, and far clip plane to 60. Now we finished setting up the virtual camera. Let's move on to the next lecture. In this lecture, we're going to be adding a character controller component to our player game object. The character controller is a non-physically realistic controller created by Unity. It's a perfect solution for our game because we can precisely control every movement of our characters. Type in character and select the character controller in the search suggestions. Set the y-axis of the center to 1. Skin width to 0.0001. That's it, the character controller is all set. In this lecture, we can be creating two scripts that we are going to be writing over the next few lectures. First, let's create a folder to hold all the scripts. Under Game folder, right-click and select Create Folder. Rename the folder to Script. Under Script folder, create a script by right-clicking and selecting Create C# script. Name the script Player Input. Create another script and name it character. Select our player game object and drag both scripts onto it. Let's double-click the player input script to open it up in Visual Studio Code for the next lecture. In this lecture, we're going to be writing our very first script. Let's open the player input script. This script is going to help us manage all the input data. First, let's create two public variables of the type float, called horizontal input and vertical input. They need to be public because we need to read these input data from other scripts. Let's get rid of start function since we don't need it. Next, let's get input data in update function. Please keep in mind that we should always capture the input data in update function rather than fixed update function, since fixed update misses key prices quite frequently. Let's get the horizontal input using input.getAccessRaw and store it in the variable horizontal input. We need to pass in the string name of the axis, which is horizontal. How do we know what the name is for the horizontal input? Let's go back to Unity. In Edit, Project Settings, select Input Manager on the left side. Under Axes Horizontal on the right side, you can see the name. You can also find the names for vertical input and other input down the list. Let's go back to Visual Studio Code and get horizontal input and vertical input with string names horizontal and vertical. One last thing, in onDisable function, we are going to reset our input data to 0. OnDisable function is a built-in Unity function that gets called every time the game object this script attached to is disabled. Because we are going to attach this player input script to the player character game object. We do this to make sure that we don't receive any input data when the character is dead or uncontrollable. In this lecture, we're going to be writing the code that moves our characters. First, let's get rid of start and update. Next, let's add a variable to hold a reference to the character controller attached to the player game object. We need to define how fast our player moves. Let's create a public variable of the type float, call it moveSpeed, and set the default value to 5f. We also set the moveSpeed variable to public, so we can change the value in the inspector in Unity anytime we want. We need a private variable to store the movement velocity of the player. Let's call it _movement velocity. Don't forget, we also need access to the player input script we just wrote. So let's declare a variable of the type player input to hold a reference to the script. Next, let's get and store references to the character controller and the player input script when the game starts. I personally prefer to get and store the references in a wake function rather than start function. A wake function is a built-in Unity function that is going to be called when an instance of this script is being loaded. It's called before the start function. The next thing to do is calculate the movement velocity for the next frame based on the player input. Let's create a function to do so and call it calculatePlayerMovement. First, we're going to set the movement velocity with the incoming player input from our player input script. We leave the value of the y-axis to 0 since we don't want to move our player upward or downward. Importantly, we need to normalize the movement velocity by calling a built-in function in vector 3 called normalize. If we don't do this, the player will move faster when it's moving diagonally. We also need to rotate the movement velocity to match the camera view angle. To do this, we use quaternion.Weller to modify the rotation to align with our camera, which is 0, minus 45, 0. And multiply underscore movement velocity by this rotation. Also, don't forget to multiply underscore movement velocity by move speed multiplied by time to make the movement smooth across frames. Time.delta time is the time passed since last frame, because we're going to be calculating the movement in fixed update every frame, and every frame could be slightly different in length in different hardware, sometimes even on the same hardware. So we need to multiply underscore movement velocity by time.delta time to make sure the movement is constant across different frames and hardware. The next thing to do is call calculate player movement from fixed update to calculate the movement velocity and move our player every frame. After the movement velocity is calculated, we can move the player by calling the move function on the character controller and pass in underscore movement velocity. Please keep in mind that we should always put the code that moves objects in fixed update function. Hit Ctrl S to save our script and return to Unity. Let's click the play button at the top to test our code. Seems like it's working perfectly, but when we walk down the stairs, the player just floats in the air and doesn't drop downwards. This is because we haven't handled the vertical movement. Let's fix this in the next lecture. In this lecture, we're going to fix the problem from the last lecture. In the character script, let's add a private variable of the type float called underscore vertical velocity. And add another public float variable called gravity. Let's initialize it with a value of minus 9.8f. Let's navigate to fixed update function. We're going to add some code to move the players downwards when it's not on the ground. How do we know if the player's on the ground or not? Unity has provided with a variable called isGrounded in the character controller. It tells us that if this game object touches the ground last frame. So let's check if underscore cc.isGrounded is false. If the answer is true, means it's floating. We want to move our player game object downwards by setting the vertical velocity to the gravity variable we just created. If the answer is not true, which means the player is grounded, what do you think we need to do here? You'd think we don't need to do anything, right? Well, your thought makes sense, but based on the way that Unity designed the character controller, we actually need to move our player game object downwards a little bit, even in the case it is already on the ground. Because if we don't move it downwards, even though the player is on the ground current frame, it is going to be floating in the air next frame automatically, and its grounded will become false. This will cause some problems later on. So let's move our player game object downwards a little bit here. Just 30% of the gravity down should be enough. The last step is to add underscore vertical velocity to underscore movement velocity. Underscore vertical velocity is a float type, and underscore movement velocity is a vector 3 type. We cannot add them together. So we need to multiply underscore vertical velocity by vertical 3.up to convert it to a vector 3. Also, don't forget to multiply underscore vertical velocity by time.delta time. Let's save our script and go back to Unity to test. Now we can see our player moves downwards correctly. I believe you've probably noticed that our player doesn't rotate in the direction of the movement. Let's fix it. Let's navigate to Calculate Player Movement function. At the bottom of the function, add a line of code that updates the player GameObject's rotation to the direction of the movement. Let's use quaternion.lookRotation to do so. I'm passing _movement velocity. Let's go back to Unity and test. The player now rotates following our input. But once we stop, the player rotates back. We don't want this to happen. Let's only rotate our player when _movement velocity is not 0, which means when we are moving. Alright, let's save our work and go back to Unity. Hit play to test. Seems like it works perfectly well. In this lecture, we're going to create an animator controller for our player. Animation controller helps us manage a set of animation clips and control which one to play based on some parameters and conditions. First, let's go ahead and create a folder to hold our animator controllers. Under Game folder, create a new folder and call it Animator. Next, in Animator folder, right-click and select Create Animator Controller. We're going to call it Player. Double-click it to open the Animator window. Let's create a new state for the idle animation by right-clicking and selecting Create State, Empty. Select the new state and rename it to Idle. In the motion slot, click the circle icon to the right, then select Little Adventure Andy _idle animation clip. Now we have an idle state with the right animation clip in it. We can see a transition arrow from entry to it. This means whenever the game starts, this animator controller is going to enter the idle state directly and play the animation clip in it. There is one more thing to do. We want our idle animation to loop. Usually, when you import animations into Unity, they're not set to loop. So we're going to set them to loop manually. Hit a Little Adventure Andy _idle animation clip in the idle state will help us locate the actual animation file in the folder. Select the root file that contains the animation clip. Find and select Little Adventure Andy _idle in the inspector. Scroll down a little bit and set Loop Time option to True. Then hit Apply to save the change. Next, let's add this animator controller to our player. Select a player game object, hit Add Component in the inspector, search and select Animator. Go to the Animator folder and drag in the player animator controller to the controller slot. Then hit the circle icon on the right side of the avatar slot and select Little Adventure Andy avatar. Let's hit play to test. There we go. The player is playing the idle animation, but it always plays the idle animation no matter what. This is because we haven't told the animation controller how to handle the other states. We move on to the animations. Let's attach the swords to the player first. This is an easy job to do. It just takes 2 steps. First, find the right bone. Next, drag the sword to the bone and tweak the transform. Let's find the bone first. Under the player game object, expand the visual game object. Then expand Little Adventure Andy game rig. Find def upper arm.l. Expand it all the way down until we see def hand.l. Go to Project Little Adventure, Mesh Asset, Character, Sword. Drag the sword onto def hand.l. Now we're going to tweak the transform in the sword in the player's hand. I've got a set of magic numbers for you here. For the position, minus 0.0004, 0.002, minus 0.003. For the rotation, 0, minus 80, 90. Now let's handle the sword in the right hand. expand def upper arm.r and find def hand.r. Drag the sword onto it like what we did with the right hand. Here are the magic numbers for the left hand sword. For the position, minus 0.0006, 0.002, minus 0.003. For the rotation, minus 164, 83, minus 87. Let's hit play to test. It seems like the swords are perfectly attached to the hand. In this lecture, we're going to be setting up the running animation. Select our player in the hierarchy and click the player animator controller in the animator component to open it up. Let's jump into our parameters and add a float variable called speed. Next, let's create a new state and call it run. Set the motion to Little Adventure Andy run. We want the run animation clip to loop. Double-click on the run state. Scroll down until we find loop time. Make sure Little Adventure Andy run is selected. Then check the loop time option. Hit apply to save the change. If speed is greater than a certain value, we know the player is moving and we want the animator controller to switch to the run state. We're going to tell the animator controller to transit from the idle state to the run state when the speed parameter is greater than a certain value, and transit from the run state back to the idle state if speed is less than that value. Let's right-click the idle state, select Make Transition, and link the transition to the run state. Next, click the transition arrow. We're going to set up the behavior and condition of the transition. We want the transition to happen immediately, so let's uncheck Has Exit Time. We also want the transition to happen smoothly, so we're going to set transition duration to 0.1. Next, let's add a condition. Hit the plus icon under the condition bar. We can see a new condition is added. The parameter is speed by default because it's our only parameter for now. The default condition is greater, which is also what we want. So we're just going to set the value to 0.1. Next, we need a transition from the run state back to the idle state. Let's right-click the run state, select Make Transition, and link it back to the idle state. Select the transition, uncheck Has Exit Time, set transition duration to 0.1, and add a condition. Set the condition to less, and the value to 0.1. We finished setting up the animator controller. Before it to actually work, we need to update the speed parameter in our code. Let's open up the character script. At the top, let's declare a variable of the type animator and call it _animator. It's going to hold a reference to the animator controller. Let's get and store the animator in a wake function. In calculate player movement function, after we figured out the new _movement velocity, we're going to set the speed parameter to the magnitude of _movement velocity. Let's jump back into Unity to test. There we go. Everything works perfectly. And if you keep the player game object selected, you can see which state is currently activated in the animator window. In this lecture, we're going to be creating the fall animation. First, we need a parameter to control when to play the fall animation. Click the plus icon in the parameter panel and select fall. Name it Airborne. Next, right-click on the empty space in the animator panel and create a new state. Name it Fall, and select Little Adventure Andy Airborne for the motion. Let's make sure the animation clip is set to loop. Double-click on the fall state, scroll down to the loop option, and check it, then apply. Let's make a transition from the any state to the fall state. Let's click the transition arrow to set it up. Set transition duration to 0. And add a condition when airborne is true. Next, let's make another transition back to the idle state. Let's uncheck has exit time option because we want this animation to happen immediately. Transition duration is 0. And the condition is when airborne is false. Now we've finished setting up the animator. Let's write the code to make the fall animation work. We just need to update the airborne parameter with the value of isGrounded in the character controller, so our animator will play the fall animation whenever the player is in the air. Let's say _animator.setBall. I'm passing the name of the parameter and the value which is _cc.isGrounded. Let's jump back to Unity and add something to the scene so that we can test the fall animation. Let's drag a stair into the scene. Now we can see that the fall animation works. We can also see the transition happening in the animator window on the right side. But we have a small problem. Something is wrong when the player walks down the stairs. This is happening because our gravity is too low, so the player stays in the air for a brief moment before it's pulled down. We can fix it by changing the gravity in the character script to -20. Now everything works correctly. Before we move on to the next lecture, don't forget to delete the stair game object we just added to the scene. In this lecture, we're going to be setting up the footstep VFX for our player. First, we are going to create a root game object to hold all the VFX game objects for our player. We want the holder to be under the visual game object. Let's right-click on the visual game object under the player. Create empty and name it VFX. Let's go to Project Little Adventure VFX folder. You can find all the VFX prefabs in the prefab folder. Let's find VFX footstep and drag it onto the VFX game object. Next, let's move the footstep VFX to the right place by changing its position to 0, 0.3, -0.5. The last thing to do is to tell the VFX not to play automatically when the game starts. I want to mention that currently there are two ways to create VFX in Unity: particle system or the new visual effects system. In this game, I created the VFX prefab with both systems because I want you to get familiar with both of them since they're all quite commonly used for different purposes. But of course, each of them requires different settings. So let's talk about how to stop a visual effect from playing automatically in this case. In the visual effect component in the footstep VFX, delete onPlay in initial event game, and you'll see initial event game is also checked automatically. By leaving the initial event name empty, this footstep VFX won't play when the game starts. In this lecture, we're going to be writing a script that manages all the VFX effects for our player. First, go to Game Script and create a new C# script. Name it Game VFX Manager. Select the player game object and drag the script to it. Double-click the script to open it up in Visual Studio Code. Let's get rid of start function and update function. We are going to include the namespace for the Unity Visual Effects system. Let's create a public variable of the type visual effect to hold reference to the footstep VFX prefab. Next, let's create a function called updateFootstep. And it takes a parameter of type bool called state. Let's check if state is true. If it is, then play the VFX. If it is not, stop playing the VFX. Let's jump back into Unity and drag in the footstep VFX game object to the parameter slot in the script we just wrote. In this lecture, we are going to be creating an animation behavior script that tells the footstep VFX when to play. Let's create a folder to hold the behavior script. Under Game Script folder, right-click the empty space and create a new folder. Name it Animator Behavior. Next, let's create a new animator behavior script in the Player Animator controller. I've already had the animator window opened here. You can select the player game object and click the player animator controller in the animator component to open the animator window. We are going to create a behavior script for the run state. Let's click Run State. Check Add Behavior in the inspector and type in the name for the script. Let's call it player_run. Hit Enter, then hit Add. Unity is going to place the new behavior script in the root folder. Let's go to Asset folder and move the script to our Animator Behavior folder. Now double-click the script to open it up. We can see this script is quite different from the other scripts. That's because it's inherited from state machine behavior, not mono behavior. We can see this script comes with 5 functions. These functions are going to be called when different things happen to the run state. They're all commented, so they won't work by default. We can pick the ones we need by uncommenting them. For our footstep VFX, we only want it to play when the player is running. So we want to tell it to play when the player is in the run state and stop playing when the player is not in the run state. Let's uncomment onState enter and onState exit. In onState enter, let's get the player VFX manager script. Then call update footstep on it and pass in true as the state parameter. We also want to make sure player VFX manager exists in the current game object first to prevent bugs. Let's copy and paste the same code into onState exit. Don't forget to change the state parameter to false since we are exiting the run state. Alright, let's save our code and jump back into Unity. Great, the footstep VFX works as expected. Before we move on to add more features to our player, let's create an enemy first. The reason we want to do this now, instead of after we finished adding all features to our player, is that we're going to be sharing the character script and the animator controller between the player and the enemies. And it's a good idea to lay the groundwork for the enemies earlier when the whole script is not too complicated. Let's create the root game object of the enemy by clicking the blink area of the hierarchy and selecting Create Empty. Let's name it enemy_01. Next, let's add the visual game object to the enemy. Go to Project Little Adventure, Mesh Asset, Character, NPC_01. Drag the NPC_01 FBX file onto the enemy game object. Let's make the enemy a little bit bigger by increasing the scale of the visual game object to 1.2. Let's delete the animator component in NPC_01. Also, we want to change its name to visual. Alright, let's reselect the enemy_01 game object and add an animator component to it. We haven't created the animator controller for the enemy yet, but we can go ahead to add the avatar here. We're going to be creating an animator override controller for the enemy. The animator override controller inherits from an existing animator controller and replaces the animations while retaining the original controller's behavior. To put it simply, the animator over controller saves us a lot of time by allowing us to reuse the existing player animator controller. Let's go to Game, Animator, and create an animator override controller. Right-click the empty space. Select Create Animator Override Controller. Let's name it Enemy1. In the inspector, we can see the animator override controller requires a source controller. Let's drag in the player animator controller to the controller slot. Now we can see the animations used in the player animator controller show up here. We need to assign the right animations for our enemy 1 to replace the original ones. Since our enemies won't be able to flow in the air, we don't need the airborne animation for them, but we still need a placeholder for the animation. So let's assign NPC1 idle to the airborne animation. For the idle animation, let's assign the NPC1 idle animation. For the run animation, let's select the NPC1 walk animation. In the next few lectures, we're going to be creating a simple AI system for enemies to move to our player. In this lecture particularly, we're going to be baking the nav mesh. Nav mesh is a part of Unity's navigation system that describes the walkable surfaces for the UI. Let's head to Windows, AI, Navigation. Now we can see the navigation window on the right side. Click Bake. Let's reduce the max slope to 0 so our enemies cannot take the stairs. We also set slope height to 0.1. Then click Bake and wait for a few seconds. Now we can see the baked nav mesh, which is the blue area. Note that the stairs are not covered because we have set max slope to 0. In this lecture, we're going to be adding a nav mesh agent component to the enemy. Nav mesh agent component is a part of Unity's navigation system that moves the AI and helps them avoid running into each other. Note that the nav mesh agent component doesn't work by itself. It has to work with a character controller. Let's select the enemy 1 game object. Click Add Component in the inspector. Search and add a character controller. This character controller's collider is in the wrong location by default. Let's bring it back to the right place by changing the center Y to 1, the radius to 1, and the height to 4. With the character controller all set, now we can go ahead to add a nav mesh agent component. Click Add Component, search nav mesh agent, and add it. The component comes with a bunch of parameters. The only one we need to tweak here is stopping distance. We want the enemies to stop when they are close to the player, then start attacking. Now stopping distance is 0, which is too close. Let's increase it to 2. Note that there is a parameter called speed. Though it controls how fast an enemy moves, we are not going to change the value here because we're going to update this value in our character script. In this lecture, we're going to be writing the code that moves our enemy to the player. As I mentioned before, we're not going to write a new character script for our player. Instead, we're going to share the same character script we wrote between the player and the enemies. So first, let's go to Game Script. Drag the character script onto the enemy. Then double-click the script in the inspector to open it up. We need to declare 3 new variables for the enemy. First, we need a public variable of the type bool that defines if this character is a player or an enemy. Let's initialize it with a value of true, meaning whenever we add a new character script to a character game object, this variable is going to be true by default. Second, we need a private reference to the nav mesh agent attached to the enemy. Last, we need a private transform variable to store the player's position so the enemy knows where to move. Let's get and store the references in a wake function. Let's say if !player, which means if this is not a player, we are going to get the nav mesh agent using getComponent function and get the player using findWithTag function on GameObject. Let's go back to Unity and set the player's tag to player, otherwise our script cannot find it with the tag. Also, we need to set the speed parameter in the nav mesh agent component to the value of move speed. There is one more thing to do here. We only want to get the player input script if this is a player. because we don't have a player input script attached to an enemy. Let's move the code against the player input script down into the else block. Now it is time to write the function that calculates the enemy's movement. Let's create a public void function and call it calculateEnemyMovement. The basic logic here is if the distance between the enemy and the player is greater than the stopping distance, we want to keep moving the enemy toward the player. Otherwise, we want the enemy to stop moving. Let's use vector3.distance and pass in the player's position to find out the distance between the enemy and the player. Then compare it with the stopping distance parameter in the navmesh agent. Let's call setDistance on the navmesh agent to move the enemy to the player when the distance is greater than the stopping distance. When we call setDistance, the navmesh agent is going to calculate the path and move the enemy to the position that we passed in. Also, we need to update the speed parameter in the animator so the enemy will play the running animation. The condition to play running animation is when the speed parameter is greater than 0.1. So let's set the speed parameter to 0.2f. In the else block, let's tell our enemy to stay where it is. We call setDistance again here, but this time we pass in the position of the enemy itself, so it'll just stay where it is. Also, we want to reset the speed parameter to 0 so the running animation won't play. Last step, let's call calculateEnemyMovement function we just wrote in fixedUpdate function. Let's check if this is a player. If it is, let's call calculatePlayerMovement function. If it is not, we are going to call calculateEnemyMovement function. These lines of code move our player down to the ground. We don't want them to run if this is an enemy. So let's put them into an if block. That's it. Let's jump back to Unity. Before testing our code, don't forget to check the isPlayerOption parameter on our player and enemy. Select the player. We can see isPlayer is checked, which is what we want. When we check the enemy, isPlayer is also checked. This is not what we want. Let's uncheck it. Now we're all set. Let's hit play to test. There we go. It works. But the enemy moves too fast. Let's lower the move speed in the enemy GameObject from 5 to 2. Now it feels better. Also, please note that the enemy cannot take the stairs, which is what we want. This is because when we baked the navmesh, we set the max slope to 0, so the stairs area was not included. In this lecture, we're going to be working on the enemy movement VFX, which is a full-step VFX. First, let's create an empty GameObject under the enemy GameObject to hold the VFX GameObject. Let's expand the enemy1 GameObject. Right-click on Visual, create empty, then name it VFX. Go to Project, Little Adventure, VFX, Prefab folder. Find Particle Full-Step Burst and drag it onto the VFX GameObject. Let's move the particle to the right position by setting the y-axis to 0.15 and the z-axis to -0.9. Now we can hit play in the Play Controls panel to preview the particle. Also, we need to delete onPlay in initial event name to prevent this particle from auto-playing when the game starts. Next, let's think about how to trigger this full-step VFX in the game. In the last full-step VFX for the player, we used animator behavior script to tell the VFX to play when the player enters run state. But this time, we want the VFX to play whenever each foot is touching the ground. So we're going to use what is called animation event, which allows us to trigger some code when the animation clip plays a specific frame, which is the frame when one foot is touching the ground. First, let's find the walk animation clip. It's in the MPC1 FBX file. You can find the FBX file in Project Little Adventure Character MPC1, where you can also locate the file by clicking MPC1 avatar in the animator controller in the Enemy1 game object, then selecting MPC1 FBX file. With the FBX file selected, find and select the MPC1 walk clip in the inspector. This is the animation clip where we send the message to the VFX from. Let's scroll down until we see events. Expand events, we can see a timeline for the animation clip. Let's move the timeline to the exact frame where the right foot touches the ground. Note that you can only drag the timeline that is above the animation preview window at the bottom, not the timeline under Events. Next, click the marker icon under Events. This is going to add a new event to the animation timeline at the current frame. In the function name, we're going to type in first footstep. This means when this animation plays this specific frame, it's going to call a public function called first footstep in any of the scripts that are attached to the Enemy1 game object. Let's add another event for when the left foot contacts the ground. Again, click the marker icon to add an event and enter first footstep. Okay, we have done setting up 2 events for the feet. Let's apply our change. Though we've got the animation events, we haven't written the first footstep function yet. Let's head to Game Script folder and create a new C# script here. Name it Enemy VFX Manager. Let's get rid of start and update. First, let's add a namespace declaration for VFX. Next, let's declare a public reference to the footstep VFX game object. Now we can write our burst footstep function. Remember, it has to be public, so the animation event can access it. In the function, we just need to tell the VFX to play. I'm showing you a different way to play a VFX, which is by sending an event called onPlay. But of course, you can also use the previous way, which is just by saying footstep.play. Let's save the script and go back to Unity. We're going to drag the Enemy VFX Manager script to the Enemy1 game object. Then drag the VFX game object to footstep variable slot. Now let's hit play to test. Here we go. The VFX works perfectly. Before we get started on this section, I'd like to take a couple of minutes to talk about some simple concepts about state management. First, what is a state? In our game, a character usually has different physical conditions. For example, moving, attacking, hurt, and dead. So we are going to give the character a property called character state, which is just an enumerated type variable to keep track of the character's current physical condition, so we know what to do accordingly. But as we add more and more states to our character, we want to manage the states in one place to avoid confusion. So in our game, we are only going to handle states in 2 functions, update function and switch state to function. So how to switch between different states? First, we handle how the character behaves in different states in update function based on its current state. Second, when we want to switch between different states, we only do it using switch state to function. Third, in switch state to function, we exit from the current state and then switch to a new state. Fourth, we write 2 switches in switch state to function, one for exiting the current state and one for entering a new state. When we are exiting from the current state, we might need to do something to clear up, so we do it in the exiting switch. The last step, when we are entering a new state, we do something in the entering switch to initiate a new behavior. Please note that this is just a simple state pattern for our game. For more complicated games, you might need to use a state machine to best manage the layers of complex behaviors. Before we create the state machine, let's update our player input script first. Select the player game object and double-click on the player input script. We want the player to attack when we left-click on the mouse. So let's declare a variable of the type ball and call it mouse button down. In update function, let's check if mouse button down is false and time.timescale equals 0. Note that we added time.timescale equals 0 as a condition, because we are going to set time.timescale to 0 later on when the pause menu is active. And then we don't want to update the input data. If the answer is true, let's get the input data using input.mousebuttondown. We pass in 0 as a parameter, meaning we want the input of the left-click button. Don't forget to reset the input data in onDisable function. In this lecture, we're going to be creating a very simple state machine for our characters. Let's get started by opening up our character script. At the top, let's declare a variable of the type enum that defines different states for our character. We're going to call it character state. To keep our code as simple as possible, let's just add 2 states for now, normal and attacking. But of course, we are going to add more states along the way. Note that what we declared is just a type, so we also need a variable of the type character state to store our player's current state. Let's create a variable of the type character state and call it current state. In our code, we're not going to change the value of current state directly. We're going to use a function to do so instead. Let's declare a function called switchState2. It takes a parameter that defines what the new state this character is entering. In the function, first we're going to check what state we are exiting and do something accordingly. Then we want to handle something according to the new state we are entering. Okay, let's use a switch statement to check the value of the current state. Remember, we are just building the general structure for now. So we don't do anything here, just put break under every case. Let's copy and paste the switch statement for the entering state part. Don't forget to change current state to new state. Last but not least, let's actually switch the state by updating the current state to new state at the end. In this lecture, we are going to be updating the character script to make it work based on the state machine we just created. First, in fixed update function, let's add a switch statement so our character can react to different states. When our current state is normal, we want to move the character just like what we did before. So let's copy the code for the movement and paste it under the normal case. Don't forget to add break. Break tells the program that we have finished handling the normal case. Next is the attacking case. Before we handle this case, let's write some code to let the program know when to switch to the attacking case. For the player, let's go to calculate player movement function. Let's check if the left-click mouse button is down and the player is currently on the ground. If the answer is true, switch to the attacking state. And return immediately. Return means we're going to stop here and the following code will not be executed. There is one more thing to do. Let's go back to switch state to function to clear the input cache by setting mouse button down in the player input script to false. Before we test the code, let's use debug.log to show a message in the console window so that we can check if the code is working. Let's jump back to Unity and hit play to test. Click on the console tag to show the console window. We can see a message shows up when we left-click in the game view. It says we just switched to the attacking state. Great, seems like the code works well. But remember, we haven't handled the attacking state yet. So if you left-click while running, the player will just keep running and there is nothing you can do to stop it. No worries, we are going to fix this by handling the attack state in the next section. In this lecture, we're going to be adding the attack state to our player animation controller. Let's open the player animation controller by double-clicking it under the animation component in our player game object. Let's create a parameter of the type trigger in the parameter panel and call it attack. Now it's time to create the attack state. But this time, instead of creating a regular state, we're going to create what is called a substate machine. A substate machine works essentially just like a state machine, except it contains multiple states inside, or you can think of it as a collapsed group of states. We use substate machines for complex actions. In this case, we use it for an attack combo for the player, which means if we left-click continually within the time window, the player is going to perform 3 different attacks in sequence. Let's change the name to attack. Right-click on the idle state and make a transition to the attack state. Select the transition and check has exit time, then set transition duration to 0.1. Let's add a new condition and select attack for the parameter. We do need to set conditional predicate and parameter value here, because attack is a trigger. Now right-click on the attack state to make a transition back to the idle state. Note that the transition arrow is gray, and we can change the settings of it. This is because transitions from a substate machine to other states are handled inside the substate machine, so we're going to deal with it later on. Now, let's make a transition from the run state to the attack state. Select the transition and check has exit time. Set transition duration to 0.1, and also add a condition with the attack parameter. Okay, now it's time to handle our attack state. Let's double-click on it. You can see on the left side is the entry node, and on the right side is the exit node. We can create as many states as we want in the middle. Let's create the first state of the attacking combo by right-clicking any blank space and selecting Create State Empty. Rename it to Combo 1. Note that the entry node is connected to it automatically. The whole creation process for all 3 combos is a little bit complicated, so we'll do it in another lecture. For now, let's just focus on making the attack animation work, which means the combo 1 state is going to be the only state we have here in the attack substate machine. Let's make a transition from combo 1 to the exit node. Select the transition arrow to tweak the settings. This time, we're going to leave has exit time checked, because we only want this combo state to transit to the next state when the animation is finished. Also, let's set exit time to 1, which means we want the animation to finish playing before moving on to the next state. And set transition duration to 0, which means we don't want to blend this animation into the next animation. Now, let's assign an animation clip to the combo 1 state. Click the circle icon to the right of motion. Select Little Adventure Andy Attacked 1 animation clip. Let's make the animation play slower by setting its speed to 0.6. It seems like we have finished setting up the animation controller. But actually, if we just finish here, then when the player finishes the attack animation, it will be stuck. It won't go back to the normal state automatically. How to tell our player to switch back to the normal state? The easiest way is to send an animation event. We just need to send an event to the character script at the last frame of the combo animation to tell it, hey, the attack animation just ended. Let's do something about it. Let's double-click on the combo 1 state to open the animation settings. While Little Adventure Andy Attack 1 is selected, scroll down until we see Events. Remember, we cannot drag the timeline under Events. Instead, we drag the timeline down in the preview window to almost the end. Now, we can add a new event at the current frame. Let's set the function name to Attack Animation Ant. Then hit Apply to save the change. Let's go back to the character script and navigate to Switch State to function. We want to play the attack animation whenever we enter the attacking state. To do so, let's say when we enter the attacking state, we're going to set the attack trigger in our player animator. The last thing to do is to handle the event we sent from the attack animation. Let's create a function. The name of the function has to be exactly the same as the event function name. So let's call it attack animation ant. In the function, we just tell the player to switch state back to normal. That's it. Now let's go back to Unity. Before testing our code, we want to get out the attack stop state machine by hitting base layer at the upper left corner and keep this animator window here, so we can see if the animator transits to the attack state when we left click. Here we go, it works. But of course, it seems a little boring because we don't have the VFX here. Also, we can still move freely when we are attacking. This is something we don't want. This is happening because we haven't handled fixed update function for the attacking state. No worries, we will be fixing these problems over the next lectures. In this lecture, we're going to be adding the sword blade VFX for the combo 1 animation. First, let's go find the VFX prefab. We're going to go to Project Little Adventure VFX prefab. Then let's expand the player game object until we see the VFX game object under the visual game object. Then drag particle sword blade 1 onto the VFX game object. We can hit the play button to reveal the blade particle effect. Next, let's open the player VFX manager script in the player game object. We can add a public variable of the type particle system called blade1. Then create a public function called playBlade1. In the function, we are just going to play the blade1 VFX. Let's jump back to Unity and drag in the VFX prefab to the blade1 parameter slot in the script. We have one more important thing to do, which is to tell the player VFX manager script to play the blade1 VFX. How? Like what we've done a couple times before, we're going to send an event from our animation clip to the script. Let's open the animator window. Double-click on the attack state to find the combo 1 state, then double-click on it to open the animation settings. Scroll down to find Events. Let's go to the frame where the player starts to swing the sword, then add a new event. Set the function name to playBlade1, which matches up with the name of the function we created in the player VFX manager script. Don't forget to hit Apply to save the change. Now let's test our VFX. There we go, it's perfect. In this lecture, we're going to write the code that controls the player's movement while the player attacks. Just like in many 3D action games, when the player attacks, we want the player to slide a short distance forward. Let's open up our character script. First, in order to know when to stop sliding, we need to know when the attack starts. Let's declare a private float called attack start time. Next, we need a public float variable called attack slide duration, which defines the duration of the slide. Last, we need a public float to define the speed of the slide. Let's call it attack slide speed. Let's jump to switch state to function. We want to mark the time the player enters the attacking state so that when the player is sliding, we know when to stop. Let's check if this is a player. If it is, set attack start time to time.time. Time.time is the current game time since the game has started. Then we want to move our player in fixed update function very fast, so it seems like the player is sliding. Under the attacking case, let's say we only want this character to slide if it's a player. The first thing to do is to reset underscore movement velocity to 0, since it might have a value from the last frame if the player was moving. Our next job is to calculate underscore movement velocity for the slide. Remember that we have a variable called attack slide duration? We want the player to stop sliding when attack slide duration is passed. So let's check that out first. Let's check if time is less than attack start time plus attack slide duration. If the answer is true, we want to move the player. For the calculation, we want to find out the percentage of the duration that has passed. Then use vector3.lerp to get the appropriate speed for that percentage. Vector3.lerp is a built-in Unity function that linearly interpolates between two vectors with a value from 0 to 1. In this case, it interpolates between our maximum speed based on the player's facing direction and 0 by the interpolant, which is the ratio of the past duration. Let's jump back to Unity and test. There we go. We can see that the player slides a short distance when attacking. In case you cannot see clearly because the movement is too short, let's tweak the duration and speed to make it more notable. Now you can see the player really slides a lot. Note that we tweaked the parameters when the game was running. The values we changed at runtime will be reversed when the game stops. So when we stop the game, the duration and speed will be reversed to the original value.
In this lecture, we're going to be handling enemy attack animation. The animator override controller we just created for the enemy is inherited from our player animator controller, which allows us to use the same state machine in the player animator but with different animations in each of the states. So we don't need to create any states or transitions again. All we need to do is just replace the attack animation. Let's just select our enemy1 game object and double-click the enemy1 animator in the inspector. Doing so will lead us to the animator in the folder. Select the enemy1 animator in the folder. On the right side, we can see the attack animation is not assigned. Click the circle to the right and select NPC1 attack animation clip. Next, we need to add an attack animation ants event to the animation clip, just like what we did for the player. Let's double-click the animation to locate the file in the folder. Then select the NPC1 file. In the inspector, select NPC1 attack animation clip. Scroll down until we see events. Drag the timeline to frame 67. Then add a new event and set function name to attack animation ants. Hit apply to save the change. Next, we need to tell the enemy when to switch to attacking state. Let's open up the character script and go to Calculate Enemy Movement. At the end of the else block, which is when the enemy is too close to the player and stops moving, we want to switch its state to attacking state. Previously, in switch state to function, we have made sure the character is going to play the attack animation whenever it enters attacking state. So we just need to call switch state to and pass in character state dot attacking. We don't need to take care of the attack animation. Let's jump back to Unity to test. Well, when the enemy is close to the player, it just stops. What is going on here? Note that there is a red warning at the bottom left corner. That means we've got an error. To see the warning clearly, let's go to the console window. It says null reference exception. Don't panic, this is a very common mistake. It just means we are trying to access a variable that doesn't even have a value or reference yet. Let's double click the warning. it's going to take us right to the line of code that causes this problem. Now we can see it's the line that we clear the input cache for our player input script. It seems like player input is null, which means it doesn't hold a reference to the script. This is probably because in the enemy OneGame object, the character script doesn't hold a reference to the player input script. We did this on purpose because an enemy is controlled by AI and it doesn't need to receive the input data. The easiest solution here is to make sure we only clear the input cache if this game object is a player. Let's add an if statement and move the lines into the block. Now we can go back to Unity and test. See, it works this time. Problem solved. But there is another small problem. The enemy doesn't rotate to the player before attacking. Let's go back to Visual Studio Code to fix it. In switch state 2, under entering attack stage, let's get a rotation that looks at the player by passing in the direction vector. Then update the enemy's rotation to it. Let's jump back to Unity. There we go. The enemy rotates to the player before attacking. In this lecture, we're going to be adding an attack VFX to the enemy. First, let's locate the VFX file by going to Project Little Adventure, VFX, Prefab. Find VFX Smash. Expand enemy OneGame object until we see the VFX game object under Visual. Drag VFX Smash onto the VFX game object. Let's set the position of the VFX Mesh to 0, 0.25, 2. We can click the play button to review the VFX. We don't want this VFX to play automatically when the game starts, so let's delete onPlay in initial event name on the right side. Next, let's open up the enemy VFX Manager script. At the top, let's declare a variable of type GameObject to hold a reference to the VFX Mesh GameObject. Let's call it AttackVFX. Next, let's create a new public function called playAttackVFX. Note that the function has to be public because we are going to send an event with the same name from the attack animation clip to this script later on. In the function, we just want to play the VFX. You can use either AttackVFX.sendEvent or AttackVFX.play. Let's go back to Unity and drag Smash VFX to the AttackVFX slot. The last thing to do is add an event to the attack animation clip. Let's locate the animation file by double-clicking the animator override controller in the enemy OneGame object and double-clicking the attack animation clip in it. With NPC1 attack selected, scroll down and add a new event. Add frame 33. In the function name, let's type in playAttackVFX, which is the same function name in the script. Let's click Apply to save the change and hit play to test. There we go. The VFX plays when the enemy attacks. In this lecture, we're going to be writing a script that handles our character's health. First, let's go to Game, Script, and create a new C# script. Name the script Health. Double-click the script to open it up. And get rid of the start and update functions. Let's declare three variables at the top. The first one is a public integer that defines the max health of the character. We set it to public so we can update its value in the editor. The second one is a public variable of the type integer called current health. The last one is a variable of the type character. Let's call it _cc. This variable is going to hold a reference to the character script because we're going to do something to the script when the character's current health is below 0. Next, in the wake function, let's set the current health to max health when the game starts. And get the reference to the character script and store it in _cc. Then we create a public function called applyDamage, which takes an integer parameter called damage. In the function, we want to subtract damage from current health and print out some information in the console, such as how much damage the character just took, and how much its current health is. Let's go back to Unity. After Unity finished compiling, let's drag the health script onto the enemy1 game object. Set max health to 100 and leave current health at 0 since we have set the current health in the wake function. In this lecture, we're going to be setting up a collider that's used for casting the damage. Let's right-click on the player game object and select Create Empty. Then let's name the new empty game object Damage Caster. Let's add a box collider component to it. Change the position of the collider to 0, 1.15, 1. Then change the size of the box collider to 1.8, 1, 2. The last thing is to set the collider to its trigger. We're going to use this box collider to test if any characters have collided with it and apply some damage to them if possible. In this lecture, we're going to be updating our character script for the character's health state. Let's open up our character script. At the top, let's add a variable of the type health that holds a reference to the health script. Next, let's get and store the reference to the health script in a wake function. Last, let's create a public function and call it applyDamage. I know we have created a function in the health script with the same name. So you might be wondering why we want to do it again here in the character script. This is because when something happens to the character, in this case, it takes damage from another character, we only want to tell the character script to do something. We don't want to skip the character script and communicate to the health script directly. Doing so will make the code messy and unmanageable eventually. To simply put it, when it comes to communicating between scripts, we want the character script to be the traffic hub. This makes the code easy to manage. Go back to our function. It takes two parameters, an integer parameter called damage, and a vector3 parameter that we don't need for this lecture, but we will need it later on for positioning the impact VFX. Let's name the vector3 parameter AttackerPOS and give it a default value by saying AttackerPOS equals to new vector3, which is 0, 0, 0. With having a default value for the vector3 parameter,
When we call this function, we don't always need to pass in the value for the attacker POS parameter. In the function, let's check if _health holds a reference to a health script first. Then we call apply damage on the health script and pass in the damage value. That's it. Let's go back to Unity and wait for the script to finish compiling. In this lecture, we're going to be writing the damage caster script. First, let's head to Game, Script, and create a C# script. Name it Damage Caster, and double-click to open it up. Let's get rid of start and update functions. We're going to declare 4 variables at the top. The first one is a private variable of the type collider that holds a reference to the box collider. The second one is a public variable of the type integer. The third one is a variable of the type string called target tag. We use this tag to identify if the game object collides with the damage caster is what we are looking for. The last one is a list of colliders. We store all the colliders of the game objects that we have applied damage to in this list, so we don't apply damage repetitively to the same game object. In a wake function, let's get the collider and disable it right away, because we only want the damage caster to work when the character attacks. Next, let's initialize the collider list, since all lists need to be initialized before using in Unity. Let's type in onTriggerInter. Then Visual Studio Code is going to suggest the function name for us. OnTriggerInter is a built-in function that gets called by Unity when a game object collides with another game object. And it only works when we have a trigger collider in this game object. In the function, we want to check if the other collider's game object is what we're looking for. Let's check that by comparing its tag to our target tag. And we also want to check if the other collider is already in our damage target list to avoid damaging the same character multiple times. Next, let's try to get the character script from the other collider. Then check if we have successfully gotten the character script. If we have, meaning we can apply damage to it by calling apply damage on it. There is one more thing to do. Let's add the other collider to our list since we have dealt with it. Next, let's create 2 public functions that enable and disable this damage caster. Let's call them enable damage caster and disable damage caster. We're going to call the enable function from the attack animation clip at the frame where the attack starts by sending an event. And we're going to call the disable function at the frame of the attack animation clip where the attack ends by sending another event. In enable damage caster function, let's clear our damaged target list and enable the collider. In disable damage caster function, let's also clear the damaged target list and disable the collider by setting damage caster collider.enabled to false. Let's go back to Unity and drag the script onto the damage caster game object. Before we type in the target tag, let's set the tag for our enemy first. Let's select the enemy1 game object. Select enemy from the tag dropdown. Then go back to the damage caster game object and type in enemy for the target tag parameter. In this lecture, we're going to be adding 2 animation events to the attack animation clip and updating the character controller script. First, we're going to locate the attack animation clip. Let's open up the animator window by double-clicking the player animator controller in the player game object. Then double-click attack state to go inside. Double-click the combo 1 state. This will lead us to the file in the folder. On the right side, make sure the attack 1 clip is selected. Then scroll down to events. Expand events. You can see we've already had 2 event markers on the timeline. Just to jog the memory, the first event is to play the attack VFX. The second event is to tell the character when the attack is finished. Now, we're going to add two more events here, one to enable the damage caster and one to disable it. Let's move to frame 4, which is where the player starts swinging the sword. Let's create a new event here. Name it Enable Damage Caster. Let's move to frame 10 and create another event. Name it Disable Damage Caster. The reason that we add the event at the middle of the timeline rather than almost at the end is that we want the player's damage window to be a little short. Like in most action games, the player's attack doesn't cause damage throughout the whole action. Otherwise, the player will be too strong. Here I'm just moving the event's position a little bit according to my personal preference. Let's hit Apply to save the change. Alright, let's review the events one more time. The first one is to play the attack VFX. The second one is to enable the damage caster. The third one is to disable the damage caster. And the last one is to tell the script the attack has ended. Great, we have finished setting up the events. But actually, this won't work if we want to test the game now. Why? The answer lies in the hierarchy of the game objects. Remember that I mentioned before, to receive the event, the recipient script has to be in the same game object that the animator controller attached to. In our case, the animator controller is attached to the player game object, whereas the damage caster script is in the damage caster game object. This means the damage caster script will never receive the events, despite it's already had the functions with the same names as the events. To fix this problem, we can let our character script receive the event and call the functions in the damage caster script. Let's open up the character script. At the top, we need a variable that holds reference to the damage caster script. Next, we want to get and store the damage caster script in the wake function. Note that the damage caster script is attached to the damage caster game object, which is the child of the player game object. So we want to use getComponent in children instead of getComponent. Let's go to the bottom and create some public functions to receive the animation events. Remember that the names of the functions have to match up with the names of the events. So let's call them Enable Damage Caster and Disable Damage Caster. In the functions, we just need to call Enable Damage Caster or Disable Damage Caster on the damage caster script. We're done here. Let's jump back to Unity to test. First, let's make sure the box glider in the damage caster game object is disabled when the game starts. Then let's select the enemy so we can see if its current health changes when the player attacks it. Here, the current health is 100. It decreases to 70 when we attack. But as you can see, if we keep attacking, the enemy's current health goes all the way down to even a negative number. We'll fix this later on when we handle the death. In this lecture and the next few lectures, we're going to be working on a couple of attack impact VFX. In this lecture specifically, we're going to be handling the slash VFX that appears when the player's weapon hits an enemy. And we're going to go through a more complicated approach to make the slash VFX appear right at the impact point. We're going to start by finding the slash VFX in the folder and dragging it to the VFX game object under the player game object. Let's head to Project Little Adventure, VFX, Prefab. Find VFX slash.
Then expand the player game object until we see the VFX game object under the visual game object. Drag the VFX slash to the VFX game object. Let's move the VFX slash a little bit so we can see it better when we hit play button to review it. Note that we don't need to care about the position of the VFX slash since we're gonna update its position via the script. Let's just leave it here and jump into the Player VFX Manager script. At the top, we're going to declare a public variable of type visual effect called slash to hold the reference to the VFX slash game object. Next, let's create a public function called play slash. It takes a vector3 parameter called POS since we need to update the position of the VFX. In the function, let's just set the position and play the VFX. Let's jump back to Unity and drag the VFX slash game object to the slash parameter slot in the script. The next step should be telling the Player VFX Manager script to play the VFX. But before that, I want to show you a trick to debug your code visually. In our case here, it would be really convenient to see if we get the right position whenever the player damages an enemy, right? Let's open up the damage caster script in the damage caster game object under the player. At the bottom, let's create a function called onDrawGizmos. OnDrawGizmos is a built-in Unity function. It draws visual references in the scene view to help us see what is going on. In the function, let's say we want to get a reference to the box collider component if we don't have one already. Wait, why do we need to do this? Didn't we get the box collider component in a wake function before? The reason we need to do this again is that onDrawGizmos runs in both game mode and edit mode. And when in editor mode, a wake function won't be executed since the game is not running. So we need to get a reference to the box collider component again in onDrawGizmos for when we are in editor mode. Okay, let's go back to what we really want to do here in onDrawGizmos. We want to cast a box that is the same size as our box collider component to test if any enemies collide with it. If we do get one, we want to draw a sphere at the collision position so we can visually check if we get the position right. Let's do it. First, we need to declare a variable of type rayCastHit to hold the result of the test. Let's call it hit. Next, let's find out the original position for our box cast. We take the position of our damage caster game object and calculate original path with offset based on half of the length of our box collider component and the facing direction of the damage caster game object. Next, we cast a box using physics.boxCast. Then pass in original path, half of the extent of the box, the direction, the variable that receives the hit result, the rotation, max cast distance, and the layer mask. Maybe you are confused with this. It's just a way to get the value of a specific layer in Unity, and physics.boxCast only interacts with game objects in the layer we've given. Let's go back to Unity and select the enemy1 game object. We can see layer is still default at the upper right corner. This won't work. Let's set it to enemy. And remember we set 6 because enemy is the 6th layer. Let's click on No, this object only to continue. Let's go back to the code. We're going to check the value of its hit if it is true, which means the box cast has collided with something. We set the color to yellow. Then draw a sphere at the impact point. Okay, let's jump back to Unity to test. Note that for onDrawGizmos to work, the Gizmos option at the upper right corner of the scene window has to be activated. Let's select the player game object first, then maximize the scene view so we can see it better. We don't need to run the game, just move the player game object closer to the enemy in the scene view. Now we can see a yellow sphere at the position where the damage caster of the player collides with the enemy. Let's keep moving and rotating our player to see if the sphere always shows up at the right point. Seems like it works perfectly. Let's shrink the scene view and reset the position of the player game object. Now let's go back to the damage caster script to finish the code. In onTriggerInter function, under the line where we apply the damage, let's try to get the player VFX manager script from our parent game object. If we do get the player VFX manager script, let's go to onDragGizmos to copy the box caster code and paste it back here. Let's say if we do get a hit result, we want to play the /VFX. Know that we pass in the point of the impact but add an offset to it. This would move the VFX higher so we can see it better. Let's jump back to Unity and test. There we go, the /VFX is showing at the right position. Now we have finished this lecture, but before we move on to the next lecture, I want to add some code to the character script to fix a potential bug. This bug won't happen now, but it might happen in the future when the player is performing a combo. In switchState2 function, under the exiting state switch statement, find case character state dot attacking, then add 2 lines of code under it. This code basically says that when the character exits the attacking state, we want to disable the damage caster in case it hasn't been disabled by the event sent from the attacking animation clip. In this lecture, we're going to be working on another VFX that appears when the enemy is being hit. Differs from the previous one. This one depicts the impact that is applied to the enemy's body. Let's go to Project Little Adventure, VFX, prefab. Find a VFX called particle being hit. Expand the enemy1 game object until we see the VFX game object. Then drag the particle being hit onto the VFX game object. Set its Y position to 1. Let's hit play in the particle effect panel to reveal it. It looks like the force that causes this impact is coming from the back of the enemy. We can rotate the VFX to stimulate the visual effect of the force coming from different angles. Let's left-click on the Y position and hold, then drag the cursor to the right to increase the Y value. Hit play to test. This is what we want the VFX to look like when the force is coming from the left side of the enemy. Let's increase the Y value a little bit more. Now, it seems like the force is coming from the front side of the enemy. This is what we want for the force that is coming from the right side of the enemy. I believe you've got the idea. Let's open up Enemy VFX Manager script to write the code. At the top, we need a variable to hold a reference to the VFX game object. Let's call it being hit VFX. The type is particle system. At the bottom, let's create a public function called playBeingHitVFX. It takes a vector3 parameter that represents the impact point of the attack. Before we play the VFX, we want to rotate it so it faces the same direction where the attack is coming.
To do this, first we calculate the direction by subtracting attack POS from the enemy's position. Then we normalize the vector so that the vector keeps the same direction but its length becomes 1. And we want to remove the pitch by setting y value of the direction to 0. Next, we use quaternion.lookRotation to calculate the new rotation that aligns with the new direction. Then update our VF-axis rotation with the result. The last thing to do here is to play the VFX. Now we have finished with the enemy VFX manager script. Let's jump to the character script and write the code to play the VFX whenever the enemy is hit. Let's go to apply damage function. At the bottom of the function, we want to check if this character is not an enemy. If it is, we get the enemy VFX manager script from it and call play being hit VFX and pass in the attacker's position. Let's jump back to Unity. Before we test the code, don't forget to assign the VFX game object to the script. Let's hit play to test. The VFX appears when we hit the enemy, but its rotation never updates. What is wrong here? I guess that's because we didn't provide the right position for the character script. Let's go to the damage caster script. In onTriggerInter function, we can see we didn't pass in the position parameter when we called apply damage in the target character. But note that the function still worked without one of the parameters. That's because we have set the default value for the position parameter, so the function will still work even if we don't pass the parameter. Alright, let's pass in the position of the parent game object, which is the player game object. Let's go back to Unity to test. This time, the VFX works correctly. We can see that it aligns with where the attack is coming. In this lecture, we're going to be working on the splash VFX for the enemy. First, let's go to Project Little Adventure, VFX, prefab. Find a VFX called VFX Splash. Next, expand the enemy 1 game object until we see the VFX game object. Now let's drag the VFX Splash prefab onto the VFX game object. Let's hit the play button in the play controls panel to preview the VFX. As you can see, it looks like the oil splashes out every time the enemy gets hurt. This VFX can be triggered multiple times in a short period of time if the player keeps attacking the enemy. So trying to play the only one splash VFX attached to the enemy won't work. What we need to do is to instantiate a splash VFX instance from the VFX prefab and play it every time the enemy gets hurt. So let's delete the splash VFX game object under the VFX game object, since we are going to instantiate new splash VFX game objects at runtime. Let's open up the enemy VFX manager script in the enemy 1 game object. At the top, let's declare a public variable of the type visual effect and call it being hit splash VFX. This variable is going to hold a reference to the splash VFX prefab game object. Next, in play being hit VFX function, let's declare a variable of the type vector3 called splash POS for the position of the VFX we are going to initiate, and set it to the position of the enemy game object. Then let's move the position a little bit up by adding 2 to the y-axis of splash POS. Next, let's use initiate function, which is a Unity built-in function to create a new game object at runtime. It takes 3 parameters,
The first one is the VFX prefab we want to initiate. The second one is the position where the new game object spawns at. The third one is the rotation of the new game object. Here we just pass in quaternion.identity, which means no additional rotation. The new game object will just align with its parent's rotation. Please note that we also declare a variable of the type visual effect called newSplashVFX to store the return value of initiate function, which is the newly created VFX game object itself. Now let's tell the new VFX game object to play by saying newSplashVFX.sendEvent on play. And we also need to destroy the new VFX game object after it's finished playing. Let's use destroy function to do so. This is a Unity built-in function. It takes two parameters. The first one is the game object that we want to destroy. The second one is the optional time delay before destroying the object. Here we want to set the delay long enough so the VFX game object won't be destroyed when it's still playing. 10 seconds should be enough. Let's jump back to Unity. Drag the VFX Splash prefab from the folder to the script and hit play to test. There we go. We can see the oil splash VFX will cause damage to the enemy. Before we wrap up this lecture, I want to make a disclaimer. The thing we did with the splash VFX game object should work fine for now. But this is going to lead to a performance issue called garbage collection if we do this a lot in a real game. Because the CPU and memory will have a hard time handling the initiating and destroying process. So if you want to make a commercial game, you should not use this approach. Instead, you should be using either object pool or dots. I won't cover these things in the tutorial since there is a lot to talk about, but it's easy to find learning material on the internet. If you're just learning to make a game for fun, then you don't need to worry about this potential issue at this moment. In this lecture, we're going to make the player and enemy blink when they get hit. First, let's check out the material that I made for both the player and enemies. Expand the enemy1 game object under the visual game object. Select NPC1 mesh game object. At the bottom of the inspector on the right side, we can see the material. There is a property called blink, and if we drag the range slider, we can see the material turns white when the value hits 1. Blink is the property that we are going to control via script to make the enemy and the player blink. But blink is just the property display name. In order to access this property in the script, we need to know its internal name. Click on the 3-dot icon at the upper right corner of the material section, then select shader. Now we're looking at the shader that this material is using. We can see blink as a property name on the right side. On the left side, we can see its internal name, _blink. Let's just take note of this name for later on. Now let's open up the character script. Before we start declaring our variables, let's take a moment to talk about how to change the properties of materials in Unity. The most intuitive way is to tell the material in the game object to change the value of a property directly. It works. But doing so will have a huge impact on performance, especially when you are updating properties throughout a lot of materials. So the most efficient way is to use what is called material property block. It helps us draw multiple objects with the same material with slightly different properties. Okay, let's start by declaring two variables. The first one is a private material property block called _material property block. The second one is a private skinned mesh renderer. Let's call it _skinned mesh renderer. We need to get the material property block from the skinned mesh renderer component of our mesh game object. Let's do it in a wake function. First, let's get the skinned mesh renderer using getComponentInChildren function since it's attached to the mesh game object under our character game object. Next, we need to initialize _skinned mesh renderer before using it. The third thing to do here is to get a material property block from _skinned mesh renderer. Now, let's go to the bottom of the script to write the function that makes our character blink. What we need for this function to do is to change the character's material to white, wait for 0.2 seconds, then change it back to the original state. Normal function cannot do this since you cannot tell the program to wait at a certain line for a certain amount of time. This is where coroutine comes in handy. A coroutine is a special function with the word IEnumerator in front of it. You don't need to know what IEnumerator is or how it works. Just remember that we can ask the program to wait in such coroutine functions. Let's write our coroutine function. Just put IEnumerator first, and we're going to call it material blink. In the function, let's update the underscore blink property in underscore material property block to 0.4. Then we're going to update the material using setProperty block function in underscore skinned mesh renderer. Otherwise, the character's material won't be updated. Next, let's tell the program to wait for 0.2 seconds. Please do not overthink this yield return new wait for seconds syntax. It's just the way it is to tell the program to wait in Unity. The last thing to do is to set the material back to the original state. Let's just copy and paste these two lines to the bottom and change the value of underscore blink back to 0. Okay, now we have finished material blink function. Let's execute this function whenever the character gets hit. Let's go to the bottom of apply damage function. This is a perfect place to call material blink function. And we don't even need to check if this character is a player or an enemy, since they both use the same material shader. Since material blink is a coroutine function, we need to use start coroutine to start it. Another thing you'd have to get used to in Unity. There we go. The enemy blinks as expected. The player will act the same way when it gets hurt after we finish the enemy's attack function later on. In this lecture, we're going to be working on the enemy death function. First, let's add a death state to the animator controller. Remember that we've created an override animator controller from the player animator controller for the enemy. So we need to go back to update the player animator controller instead. Let's select the player game object and double-click the player animator controller under the animator component. Then go back to the base layer and right-click to create an empty state. Rename the new state to dead and set motion to little adventure ending underscore dead. Next, let's add a new trigger parameter in the parameter panel. Name it dead. Let's make a transition from the any state to the dead state. Select the transition arrow, scroll down and add a new condition. And select the trigger parameter dead. We're going to set transition duration to 0.1. Let's select the enemy 1 game object. Double-click the enemy 1 animator controller. Let's set an animation clip override for the dead state. Select the NPC 1 dead animation. Next, let's update the code. We're going to open up our character script. Let's go to the character state enum declaration to add a new state called dead. Then we're going to update our switch state to function. Let's add the case for that to both the exiting state switch and the entering state switch. In the exiting state switch, instead of adding break, we're going to add return. A dead character should always remain dead no matter what, so we don't want any character to exit the dead state. By putting return, we can make sure that switch state to function will just stop right here, and all the following code won't be executed. In the entering state switch, let's check if we are entering the dead state. If we are, we want to disable the character script. Then, we want to trigger the dead parameter in the animator controller to play the dead animation. Then don't forget to put break at the end. Next, let's update fixed update function. We're going to add a case for the that state in the switch statement. And we just need to write return to stop all the following code from being executed. Because when the character is dead, we don't want to do anything in fixed update function. Now let's go to our health script. We're going to create a function to check the health status whenever the character takes damage. Let's create a private function called checkHealth. Let's check if current health is below 0. If it is, we want the character script to switch to the dead state. Looks like we can access switch state to function outside the character script. We must have made it a private function. Let's go back to the character script to make switch state to function public. Don't forget to save the script before we go back to the health script. Now we can call switch state to function on_cc to tell it to switch to the dead state when current health is less than 0. Don't forget to call checkHealth function at the end of applyDamage function. Let's go back to Unity to test. It works. The enemy dies when its health is less than 0. In this lecture, we're going to be handling the material dissolve effect that takes place when the enemy dies. First, let's go check out the property in the shader that we're going to tweak in the code for the dissolve effect. Let's expand the enemy1 game object until we see the NPC1 mesh. Select it. On the right side, we can see a property called dissolve height under the material component. Note that the material won't change if we only change the value of dissolve height. That's because we have another property right above called enable dissolve. We have to switch it on first. Now the material dissolves when we lower dissolve height. Okay, let's reset the material of the enemy1 game object by switching off enable dissolve. Now we go to the shader of this material to check the property's name. We can see the names are _enable dissolve and _dissolve height. These are the actual names that we are going to change in the script. Let's head to our character script and scroll all the way down to the bottom. Let's create a coroutine function called material dissolve. Don't forget the IEnumerator keyword before the function's name. We don't want the material to dissolve right after the enemy is dead. We want to wait for 2 seconds. Let's do it by saying yield return new wait for seconds 2. Next, we're going to claim a bunch of float variables. Dissolve time duration for how long this effect is going to last. Current dissolve time to keep track of how long this effect has lasted. Dissolve height _start for the initial value of the height. Dissolve height _target for the target value of the height. And the last one, dissolve height, which is the current value of the height. We're going to change this value so it seems like the enemy is dissolving. Before we start changing the material property, don't forget that we need to switch on _dissolve property first. We can do this using setFloat function in _material property block and set the value to 1. Next, let's update the change we just made by using setPropertyBlock function. Now we're going to animate the height property in a while loop. Let's say while current dissolve time is less than dissolve time duration. In the while loop, let's update the current dissolve time by adding time.time to it. Then let's update the dissolve height property. We use mathf.lerp function to find out the new value for it. Let's pass in the start value and end value.
then pass in the interpolation value. Lerp function is going to return the interpolated flow result between the start and end values after we get the current height value. We're going to set the underscore dissolve underscore height property in the material property block. And update the block in the skinned mesh rendered component. The last thing to do is to tell the while loop to wait for 1 frame before we change the material next time by saying yield return null. Let's copy the name of this function and go to switch state 2 function. Under case character.dat in the switch block for when the character is entering a new state, which is when the characters die. We want to call the coroutine function we just wrote by saying start coroutine material dissolve. Let's jump back into Unity and test our code. Just want to remind you once again, please be cautious and save your project and your scripts whenever you're going to test the code that includes while loops. Because if anything goes wrong in the while loop, Unity will crash and you are going to lose all the unsaved work. Let's hit play and keep attacking the enemy. Wait for 2 seconds, then we see the enemy dissolve. In this lecture, we're going to create a simple heal warp item and make it a prefab. Right-click in the hierarchy and select Create Empty. Change the name of the new game object to heal warp. Reset its transformation on the right side. Now the heal warp game object is overlapped with our player game object. Let's move it forward a little bit by dragging the blue arrow. We're going to go to the prefab folder in the VFX folder and drag the particles heal warp visual game object onto the heal warp game object. Change its name to visual. Let's go to the game folder and create a new folder called prefab. Let's get into the prefab folder and drag the heal warp game object into the folder to make it a prefab. Note that the name of the heal warp game object turns blue, which means it's a prefab now. In this lecture, we're going to be updating the code to make the enemy drop an item when it dies. At the top, let's declare a public variable of the type GameObject called itemToDrop, which is going to hold reference to the item GameObject that we want this character to drop. Let's scroll all the way down to the bottom to write our dropItem function. We're going to create a public function and call it dropItem. First, we want to check if we have an item to drop. If we do have the item, we want to initiate the item at the character's position. Let's pass in item to drop. Then pass in the position and the rotation, which is quaternion.identity, which means no rotation. Then in material dissolve function right above, we want to call dropItem function at the end, which means we're going to drop an item when this character is fully dissolved. Let's go back to Unity. Delete the heal warp game object in the hierarchy since we're going to initiate the item in runtime. But don't forget to select the enemy1 game object and drag the heal warp prefab to item to drop parameter slot in the character script. Now let's hit play to test. There we go. But we cannot collect this warp now. Let's make it collectible over the next few lectures. In this lecture, we're going to be adding the damage caster to the enemy and writing the health script for the player. In order for the player to be damaged, we need to add a health script to it. Let's select the player game object. Click Add Component on the right side in the inspector. Then type in health to find the script we have written. Let's set max health to 100. Next, the enemy needs a damage caster so it can detect the player and apply damage to it. Let's select the damage caster game object under the player game object. Right-click, copy. Then let's select the enemy1 game object. Right-click on it, then select Paste as Child. Now, a damage caster game object has been added to the enemy game object. On the right side, we can see target tag is still enemy and the damage is 30. These are not what we want. Let's increase damage to 50, which means every time the player gets hit by an enemy, it loses 50 health. Also, let's change target tag from enemy to player. We need to enable the damage caster when the enemy is attacking and disable it when the enemy is not. Let's do this by sending some events from the enemy's attack animation to the damage caster script, just like what we did for the player. Select enemy 1 game object and double-click the enemy 1 animator controller to locate it in the folder. Then select enemy 1 animator controller in the folder. Double-click NPC 1 attack animation on the right side to locate the animation file. Now, select NPC 1 in the folder. On the right side, make sure NPC 1 attack animation is selected and scroll down to find the events. Expand the events tag. Let's move to frame 33. And add a new event. Rename it to Enable Damage Caster, which matches the name of the function we wrote in the Damage Caster script. Then, let's move to frame 55, which is where we want the Damage Caster to disable. Let's add another new event here and call it Disable Damage Caster, which is also the same name as the function we wrote in the script. Hit Apply to save the changes. We can see that the player blinks when it gets hurt and dissolves when it dies. This is because all the update we did for the material also works with the player automatically, since the player shares the same character script and material shader with the enemy. The weapons don't drop from the player's hand and still stick in the air after the player dissolves. Let's fix this in the next lecture. In this lecture, we are going to make the player drop the weapons after it is defeated. First, let's head to the script folder under the game folder. Create a new script and call it Drop Weapons. Double-click the script to open it up in Visual Studio Code. Next, let's declare a list of game objects for the weapons that we want to drop. Then let's create a public function called Drop Weapons. Let's use a for each loop to go through all the game objects in the list. By the way, we note that something is wrong with our function name. Let's move the cursor over it. It says member names cannot be the same as their enclosing type. Seems like we need to rename the function. Let's call it drop sorts this time. Now let's go back to our for each loop. Before we drop a weapon, we need to add a rigid body component and a box glider component to it. Otherwise, it won't be able to respond to the physics. Now let's drop the weapon by setting its parents to null. Let's go back to Unity. Select the player game object. Drag drop weapon script to it. Click the Add button under Weapons twice to add 2 slots in the list. Then find the weapon game objects under the visual game object and drag them to the slots. Now, we have one more thing to do. Send an event to the drop weapon script from the player's death animation. Let's find the death animation just like what we did before. Let's move to frame 14 and add a new event called Drop Weapons, which is the same name as the function we just created in the script. Hit Apply to save the change. Let's hit play to test.
Let's hit pause here so we can see the weapons drop frame by frame. Let's hide the enemy for now so it doesn't block our sight. There we go, the weapons drop from the player's hands and land on the ground naturally. In this lecture, we are going to add a being hit state to our character script and animator controllers so that the player and enemy can play the hit animation and do something accordingly. First, let's add a being hit state to the player animator. Let's select the player game object and double-click the player animator to open the animator window. Let's add a new trigger in the parameter panel and call it being hit. Next, right-click in the empty space and create an empty state. Rename the new state to being hit. Assign the little adventure Andy hurt animation to it. Now let's make a transition from any state to being hit state. Click the transition arrow, then expand Settings. Set transition duration to 0.1, then add a condition. Select being hit from the drop-down. Next, let's make a transition from being hit state to idle state. Select the arrow, set exit time to 1 and transition duration to 0. Alright, we have added a new state to the player animator. Next, let's add a new being hit state to our character script. Find the declaration of character state enumeration. Let's add a being hit state at the end. Remember, every time we add a new state, we need to update two functions, fixed update and switch state 2. Let's go to fixed update. At the end of the switch block, add a new case for being hit state. Instead of writing break here, we're just going to write return so that all the following code won't be executed when this character is being hit. With the change we just made, we also need to move movement velocity equals to vector 3.0 from attacking state down to the end of the if block to prevent some bug. Now let's go to switch state 2 and handle exiting state and entering state for being hit state. Let's add a new case for being hit state in exiting state switch block. Then just break. Let's tell the character to play the correlated animation by calling setTrigger on the animator and passing in the trigger parameter being hit. Don't forget to write break. Next, let's create a public function called beingHitAnimationEnds. We are going to call this function at the end of the being hit animation so that our character script knows it is time to switch back to normal state. In the function, let's say switch state to character state.normal. There is one more thing to do. We need to tell the script when to switch to being hit state. We want this to happen whenever this character is damaged. So let's go to apply damage function. At the bottom, let's check if this is a player. And if it is, we want to switch state to being hit state. Note that our enemies won't react when they are being hit. They'll just continue doing whatever they are doing. This is a part of our game design. Let's jump back to Unity to test. Let's pause here. With the player game object being selected, we can see the animator is playing being hit state. Let's switch to the scene view. We can see the player is playing being hit animation. This means everything works as expected. In this lecture, we are going to be adding an impact to push the player backward when it gets hurt. First, let's open up our character script. At the top, we need to declare a new private vector3 variable to store the impact. Next, let's scroll down. Under Apply Damage, let's create a new private function that helps us calculate the impact. Let's call it addImpact.
It takes two parameters. The first vector3 parameter tells us where the attacker is, so we can calculate the direction of the impact. The second one is a float that represents the intensity of the force we want to apply to the player. In the function, the first thing we do is find out the direction of the force by subtracting attacker's position from the player's position. Next, we want to normalize the direction and remove the rotation of the y-axis. Last, we want to multiply the direction by the force parameter and store the result in impact on character variable we just declared. Let's go back up to apply damage under the line that we switch the player state to being hit. We are going to call add impact and pass in the attacker's position and 10F for the intensity of the force. Now we have figured out the force. The next thing we are going to do is move the player every frame so it looks like the player is being pushed back by the force. Let's do it in fixed update under the case for being hit state. Let's say if the magnitude of impact on character is bigger than 0.2f. We want to move the player. And after that, we want to consume the force so it becomes smaller and smaller. Eventually, the force will decrease to less than 0.2f. Then the player won't be affected by it anymore. Okay, let's jump back to Unity to test our code. There we go. The player is pushed back when it gets hurt. In most games, the player will become invincible for a brief moment after it gets hurt. This is what we are going to be doing in this lecture. Let's go to our character script. At the top, let's declare two variables. The first one is a variable of type bool. It marks whether the player is invincible. The second one is a float. It defines the duration of the invincibility. We initialize it to 2. Next, let's go to apply damage. At the top of the function, we want to check if this character is invincible. If it is, we want to return right here so that the following code won't be executed and the character won't be damaged. Now, we want to create an IEnumerator function that turns the invincibility off after 2 seconds. Let's call it delay cancel invincible. In the function, we will just wait for the invincible duration, which is 2 seconds. Then set is invincible to false. Next, we want to enable the player's invincibility after it gets damaged. Let's do it in switch state 2. In the case that the character enters being hit state, we'll just say if this is the player, set is invincible to true, and call delay cancel invincible to disable invincibility 2 seconds later. In this lecture, we're going to be writing the code for our heal verb. Before we jump into the code, we need to add a trigger collider to the heal verb prefab so the player can interact with it. Let's go to Game, Prefab. Double-click the heal verb prefab to open it. Click Add Component on the right side. Search for Sphere Collider. Move the sphere collider a little bit up by changing the center y-axis to 0.5. Since our prefab has the auto-save option checked, we don't need to save the changes we just made. But if yours is not checked, don't forget to save by hitting the Save button. Okay, let's go to Game, Script, and create a new C# script here. We're gonna call it Pickup and open it up in Visual Studio Code. let's get rid of start and update functions. We're going to have two types of pickup items in this game, heal verb and coin. Because their functions are very simple, we're going to just define the two types here and use the same pickup class for the two items. Let's declare an enum that contains the two types, heal and coin. Now, let's declare a variable that stores the type of this item. And a public variable of the type integer called value, which defines how much value the player is going to get from collecting this pickup item. Next, let's create a function called onTriggerInter. This is a Unity built-in function. It's going to get called whenever this game object is overlapped with another game object. Let's check if the other collider that entered this trigger attaches to the player by comparing its tag to player. If the result is true, we want to get the character script from the other collider, then call a function on it called pickup_item, and pass in this pickup script instance as a parameter. Note that pickup_item function is underlined in red. This is because the function doesn't exist in the character script yet, but we are about to write it. The last thing to do is to destroy the pickup item in the game scene. We do it using destroy function. Okay, it is time to write pickup_item function in the character script. Let's select the character text here and press F12 to jump to the script. Scroll down all the way to the bottom. Let's create a public function called pickup_item, which takes the parameter of the type pickup called item. In the function, we use the switch block to check the type of the item and handle it accordingly. So if the type is heal, we call addHealth. Then pass in the value for the item parameter. If the type is coin, we call addCoin instead. Then pass in the value for the item parameter as well. Now let's create our addHealth and addCoin functions. We don't have a variable that stores the coin value for the player, so let's add it at the top. Let's declare a public variable of the type integer called coin. Go back to addCoin function. We're going to add the coin value we get from the parameter to the coin variable we just created. For addHealth function, we're going to add something to the health script first. Let's press Ctrl P and type in health to get to the script. At the bottom, we want to create a function called addHealth that takes an integer parameter called health. In the function, we're going to add the health parameter to current health. Then we're going to make sure current health is never going to exceed max health. Now we can go back to the addHealth function in the character script and call the addHealth function on the health script init. Let's jump back to Unity. Make sure we're still in the prefab edit mode. And the heal verb root game object is selected. Drag the pickup script to it. Make sure the type is heal and leave the value as 20. Let's exit the prefab edit mode. Select our player and hit play to test. See, when we get attacked, the player's health decreases to 50. Now a heal verb spawns after the enemy disappeared. There we go, we can see the player's health restored to 70 after it collected the verb. In this lecture, we're going to be adding a VFX for when the player collects a heal verb. First, let's go to Project Little Adventure, VFX, Prefab, and find a prefab called VFX Heal. Next, expand the player game object until we see the VFX game object under the visual game object. Then drag the VFX Heal prefab onto the VFX game object. Let's select the player game object and open up the player VFX manager script by double-clicking it in the inspector. At the top, we're going to declare a public variable of the type GameObject called Hue, which holds a reference to the VFX Hue prefab. At the bottom, we're going to create a new public function called playHueVFX. In the function, let's just say Hue.play. Let's jump back to Unity and drag in the VFX Hue prefab to the Hue slot in the script. Next, we're going to tell the player VFX manager script to play the VFX whenever the player collects a Hue verb. Let's do this in the character script. In addHealth function, let's get the player VFX manager script and call playHueVFX. There we go, it works. But we have a small problem here. The Hue VFX plays automatically every time the game starts. It should be easy to fix this. Just select the Hue VFX prefab and delete onPlay in the initial event name like what we have done many times before. Now the VFX doesn't play when the game starts.
In this lecture, we're going to be setting up the animator for the player's combo. Let's open the animator window by double-clicking the player animator in the player GameObject. Right-click in the empty space, select Create State Empty. Rename the state to Combo 2. Set motion to Little Adventure Andy Attack 2, and set the speed to 0.6. Let's repeat the last step. Rename the state to Combo 3. Set motion to Little Adventure Andy Attack 3 and set the speed to 0.6. Now let's make transitions between Combo 1 to Combo 2. Select the transition arrow and check Has Exit Time. Set transition duration to 0. Add a new condition, then select Attack. Next, let's make a transition from Combo 2 to Combo 3. Select the transition arrow and check Has Exit Time. Set transition duration to 0. These transitions from Combo 1 to 2 to 3 are for when the player continuously performs the combo. But we also need transitions from Combo 2 and 3 back to the exit state, because the combo could stop earlier if the attack key is not pressed within the time window. Let's make a transition from Combo 2 to exit. Select the arrow. This time, we're going to leave Has Exit Time checked. Set exit time to 0 and transition duration to 0.1. Let's repeat the last step with Combo 3 and exit. We also want to check the transition between Combo 1 and exit. Transition duration is set to 0 here. Let's change it to 0.1. Okay, now we have done with all the transitions. Let's add some events to the animations for Combo 2 and 3. Select Combo 2. Scroll down to find event and expand it. Here, we are going to add 4 events. The first one is for the blade VFX to play. The second and third ones are to enable and disable the damage caster collider. And the last one is to tell the character script that we have finished the attack animation. Let's add the first event at frame 3 and call it PlayBlade02. At frame 4, let's add the second one. Let's call it Enable Damage Caster. Go to frame 11. Add the third one called Disable Damage Caster. The last one is at frame 16. The name is Attack Animation Ends. Okay, let's hit Apply to save the events. Let's select Combo 3 and repeat the last step. The first event is at frame 2 called PlayBlade03.
The second one is at frame 5. The third one is at frame 10. The last one is at frame 16. Alright, let's hit apply to save. In this lecture, we're going to be adding Blade/VFX for combo 2 and 3 animations. First, let's head to Project Little Adventure, VFX, Prefab. Then expand the player game object until we see the VFX game object under the visual game object. Drag particle store Blade 2 and 3 onto the VFX game object. We can check out what these VFX prefabs look like by selecting them. Let's open up the Player VFX Manager script. At the top, we need two variables to hold the references to the VFX prefabs. Let's call them Blade 2 and Blade 3. Let's select playBlade1 function, copy and paste it twice. Change the new function's name to playBlade2 and playBlade3. Also, the VFX variables in them should be changed to Blade 2 and Blade 3. We also need a new function called stopBlade. This is to stop all the blade splash VFX when the player's attack animation is interrupted. In the function, let's call blade1.stimulate0 and blade1.stop. Copy and paste the two lines of code twice. And change the variables names to Blade 2 and Blade 3. Let's go back to Unity and drag in the VFX prefabs to Blade 2 and Blade 3 parameter slots in the script. In this lecture, we're going to be writing the script for the player's combo. Let's open up our character script. At the top, we're going to declare a private variable of the type float called attack animation duration. Next, let's head to fixed update function. Under case character.attacking, we want to check if the mouse button is down and the player is still on the ground. If the answer is yes, we want to get the name of the attack animation that is currently playing. We can do this using getCurrentAnimatorClipInfo in _animator. And store the name in a string variable called currentClipName. We also want to know how long the animation has played. We can get the value using getCurrentAnimatorStateInfo in _animator and store the return value in attack animator duration. The return value is a float from 0 to 1. 1 means it's at the end of the animation. 0.5 means in the middle. We need this value because we only want the player to perform the next combo when the attack button is pressed in a short time window. If the attack button is pressed out of the window, the combo will stop. Now let's check what the current animation's name is. We only want to play the next combo when it's either combo 1 or combo 2. If it's combo 3, there's no next combo. In case you don't remember the animation's name for combo 3, let's go back to the animator window to check. And we are going to add another two conditions to define the time window. When attack animation duration is bigger than 0.5, less than 0.7. Okay, now let's write the code that performs the combo. First, we need to clear the input cache. Second, let's tell the character to switch to the attacking state. By doing this, it will automatically perform the next combo. The last thing to do here is to calculate the movement. There is one more thing to do. When we perform the next combo, we want to stop the blade VFX for the last combo right away. Otherwise, it might overlap with the VFX for our next combo. Let's go to switch state to function. Under case character.attacking in the axis state switch, we want to check if this is a player. If it is, we want to stop the previous combo VFX. Okay, let's jump back to Unity. Before we test our game, we want to go find our enemy animator and assign placeholder animations to attack 2 and attack 3. Our enemy cannot perform a combo, but since its animator is inherited from the player's animator, we'll have to fill out these animations with placeholder animations. It doesn't matter what the placeholders are, since they will never be played, but we'll get an error if we don't do this. Now we can hit play to test. There we go! I can perform the combo by left-clicking 3 times within the time window. Also, we can end the combo earlier if we don't keep left-clicking.
In this lecture, we're going to be setting up the animator for the dash animation. First, let's open up the animator window. In the parameter panel, we're going to hit the plus button and add a parameter of the type trigger. We're going to call it slide. Next, let's right-click in the empty space to create a new state. Rename it to slide. Set motion to Little Adventure Andy roll. Now let's make a transition from the idle state to the slide state. Select the transition arrow and check has exit time. Set transition duration to 0. Then add a new condition. Select the slide trigger. Let's make another transition from the slide state back to the idle state. Select the arrow. We're going to leave has exit time checked this time. Set exit time to 1 and transition duration to 0. Next, let's make a transition from the run state to the slide state. Select the transition and check has exit time. Set transition duration to 0. Then add a new condition. Select the slide trigger. Now let's double-click the slide state to open the animation file. We're going to add an event sending from the roll animation clip to our character script. This event is going to tell the character script when the slide animation is finished. Make sure the roll animation is selected. Scroll down and expand events. Let's go to frame 11 and add a new event. Let's call it slide animation ends. Hit apply to save the event. In this lecture, we're going to be updating our player input script so we can detect when the slide key is pressed. We're going to use the space key for the slide action. At the top, we're going to declare a public bool called space key down. In update, we want to check if space key down is false, which means the space key is not pressed. And time.timescale is not 0, which means the game is not paused. Then we're going to get the input for the space key using input.getKeyDown. Let's pass in keycode.space. The last thing to do is to clear the value of space key down in onDisable function. In this lecture, we're going to be writing the script for the player to dash. In our character script, let's declare a new public variable of the type float at the top. We're going to call it slide speed. It defines how fast the player moves when it dashes. Let's give it a default value of 9. Next, we need to add a new state for the character. In the character state declaration, let's add a slide state at the end. Remember, every time we add a new state, we need to update 2 functions, switch state 2 and fixed update. Let's head to switch state 2 first. At the bottom of the switch block for exiting state, let's add a new case for character.slide. And we're going to just break here. Next, at the bottom of the switch block for entering state, Let's add another new case for character.slide. Let's tell the animator to switch to the slide state by setting the slide trigger. We also want to create a new function to receive the slide animation ends event sent from the animation. Let's create a new function with the same name as the event, slide animation ends. In it, we just switch the state back to normal. Alright, next, let's update fixed update function. Let's add another new case for character.slide in the switch block. We want to move the player forward every frame when it's sliding. So let's add underscore movement velocity to our character's current forward direction times slide speed times time dot dot time. Then don't forget to break. Next, let's go to calculate player movement function. We're going to tell the player to switch to the dash state when the conditions are met. Under the first if statement, let's add an else if block. The conditions are when the space key is pressed and the player is on the ground. Then we tell the player to switch to the dash state. And we return here, so the following code is not going to be executed. We need to clear the space key cache every time we switch state. Let's go to switch state to function. In the first if block, we can see we used to clear each input variable manually by setting their values to 0. This works, but it's a little messy. Let's delete the code and create a clear cache function in our player input script. Let's copy and cut the code in onDisable, paste it in clear cache. Then call clear cache in onDisable instead. Go back to the character script. In the if block, let's call clear cache on underscore player input. Let's go back to Unity. Before we test the code, let's assign a placeholder animation to the enemy's animator like what we did before to prevent the error. We're just going to select the idle animation for roll. It doesn't matter what the animation is since it will never be played. Now we can hit play to test. There we go, the player rolls when we press the space key. We have finished everything with our player and enemy 1. Let's create our second enemy, which inherits most of the functionalities from our enemy 1, but also with some different behaviors. It attacks long range and shoots projectiles. In this lecture, we are going to be setting up the enemy 2 game object. First, let's right-click on the enemy 1 game object and select Duplicate. Move the new enemy to the right a little bit. Then changes its name to enemy 2. Expand it since it doesn't do the melee attack. We can delete the damage caster game object. Next, we're going to go and find a mesh model for a new enemy. Go to Project, Little Adventure, Mesh Asset, Actor, NPC2. Drag NPC2 mesh file onto the enemy 2 game object. Remove the animator component in it. Then expand the visual game object. Move the VFX game object under it to NPC2 game object. The rest of the game objects in the visual game object are not needed, so we can select the visual game object and delete it. Now we're going to rename the NPC2 game object to visual. In this lecture, we are going to be setting up the animator for enemy 2. First, let's create a new animator for our enemy 2. We're going to go to Game, Animator, select enemy 1 animator and Ctrl D to duplicate it. Rename it to enemy 2. We need to replace all the animations on the right side. We are about to select some other files. You can click on the lock option to prevent losing focus on the right side while we are doing so. Let's go to Project Little Adventure, Mesh Asset, Actor, NPC2.
Click the little arrow to the left of the MPC2 mesh file to expand it. Be careful, you might lose focus on the right side if you didn't click on the lock icon. Drag MPC2 idle in to replace the airborne animation. The enemies never play the airborne animation, so it doesn't matter what the placeholder animation is. Drag MPC2 shoot in to replace attack 1, 2, and 3. Also replace the dead, hurt, and idle animations. Replace the roll animation with idle, then replace the run animation with walk. Alright, let's uncheck the lock option. Next, select the MPC2 mesh file. Let's check if walk, shoot, and idle animations are set to loop. Because when we import the animations into Unity, they're not looped by default. Select these animations and make sure loop time is checked. Notice that hurt and dead animations should not be set to loop. Now let's add a new event to the shoot animation to tell our character script when the attack animation is finished. Select the shoot animation. Go to frame 74. Add a new event called attack animation ends. Hit apply to save the change. Let's select the enemy 2 game object. Note that the animator controller here is still the enemy 1. Let's replace it with the new animator we just created. Check the little circle here and select enemy 2. We also need to replace the avatar under the animator controller. We are going to do it by clicking the little circle to the right of the avatar and selecting MPC2 avatar. The animator is all set. Let's disable the enemy 1 game object, then we can test our enemy 2. Now we can see the animations on enemy 2 work well. Except it acts like the old enemy 1. It walks up close to the player, then starts shooting. This is not what we want. Let's change its behavior in the next few lectures. In this lecture, we're going to be setting up the damage warp for enemy 2 to shoot as a projectile. First, we're going to right-click in the hierarchy to create a new empty game object. Let's give it a name. We're going to call it damage warp and reset its transform. Let's go to Project Little Adventure, VFX, Prefab. Drag particle damage warp visual prefab onto damage warp game object. Rename the prefab to visual. Select the damage warp game object and move it away from the player so we can see it better. Let's add a sphere collider to it and set the collider to its trigger. Next, let's add a rigid body and set it to its kinematic. This means the game object will ignore the physics and gravity. It'll only move the way we tell it to move. I want to pause here to emphasize the reason why we added a rigid body to the damage warp. In Unity, if you want 2 colliders to interact, at least one of them needs to have a rigid body. Since our player game object have a rigid body already, we don't actually need to add another rigid body to the damage warp if we just want these 2 to interact with each other. So why do we still add a rigid body to the damage warp anyway? That's because apart from the player, we also want the damage warp to hit the walls and pillars and maybe other things in the environment. And guess what? These things don't have rigid body. That's why we need the damage warp to have a rigid body. In this lecture, we're going to be writing the script for the damage warp. We're going to start by going to Game Script and creating a new C# script. Let's call it damage warp. Double-click to open it. Let's get rid of start function and update function. At the top, we need to declare 4 variables. The first one is a public float called speed, and let's initialize it to 2. It defines how fast the warp travels.
The second one is a public variable of the type integer called damage. We're going to initialize it to 10. This is the damage that's going to apply to the player. The third one is a public variable of the type GameObject called hitVFX. It holds a reference to the VFX prefab that appears when the verb hits something. The last one is a private variable of the type rigidbody called RB. It stores a reference to the rigidbody component. Next, we want to get and store the rigidbody component to RB in a wake function. We are going to move the verb in fixed update function. Please remember, we always want to put the code that moves our game objects in fixed update instead of update. We are going to move the verb using a built-in function in rigidbody called movePosition, then pass in the new position, which is our current position plus our facing direction times the speed and time. Next, we're going to handle the situation when this verb collapses with another game object. We're going to do it within onTriggerInter function. First, we want to check if the other game object is the player. Let's declare a variable of the type character and call it CC. Then we try to get the character script from other and store the result in CC. Next, let's check if CC is not null, and if isPlayer in the character script is true. If the answers are all true, we know the other game object is the player and we can apply damage to it. If either of the answers is false, meaning the other game object is either an environment object or an enemy, we don't need to apply damage to them in this case. The last thing to do is to initiate a hitVFX at the verb's current position, and then destroy our verb. Let's jump back to Unity. Drag damage verb script to damage verb game object. Note that the speed is 2 and the damage is 10. Let's go to Project Little Adventure, VFX, Prefab, and drag particle bullet hit prefab into the hit VFX slot. Now let's move the damage verb a little bit away from the player. Then hit play to test. Let's pause the game to check the player's health after the damage verb hits the player. The player's current health is decreased by 10 to 90, meaning the damage has been applied correctly. Let's stop the test and move the damage verb to the back of the enemy. We want to check what would happen when it hits the enemy. After it hits the enemy, pause the game to check the enemy's health. The current health is still 100, meaning the damage verb hit the enemy but did not apply any damage. This is exactly what we want. There is one last condition we need to check. We need to make sure the damage verb can hit the wall. Let's move the damage verb close to the wall. And hit play. There we go, it hits the wall and self-destroyed. Okay, now we are done writing the script. Before we move on to the next lecture, let's convert our damage verb game object to a prefab so we can initiate it in runtime. Let's go to Game, Prefab. Drag the damage verb game object into the folder to make it a prefab. Then delete the damage verb game object in the hierarchy. In this lecture, we're going to be writing the script that shoots the damage verb from enemy 2. We are going to start by creating a shooting point game object under enemy 2. Let's right-click on the enemy 2 game object and select Create Empty. We are going to name it Shooting Point. We want to visualize the shooting point game object in the scene. We're going to do it by clicking the cube icon at the top left corner of the inspector and selecting a yellow label. Then we're going to set the position of the shooting point game object to -0.31.
1.14, 1.3, which is the weapon position when MT2 raises its left arm to shoot. Next, go to Game Script and create a new C# script. Call it enemy2 shoot. Let's open up the script and get rid of start and update functions. First, let's declare a variable of the type transform that holds a reference to the shooting point GameObject's transform. Next, we need a variable of the type GameObject to hold a reference to the damage verb prefab. Now let's create a public function called shootTheDamageVerb. Within the function, we want to initiate a new damage verb at the shooting point position. The rotation is also aligned with the shooting point's forward direction. Let's go back to Unity and drag enemy2 shoot script to the enemy2 GameObject. Then let's assign the shooting point GameObject and go to Game Prefab. Drag the damage verb prefab into the variable slot in the script. Alright, next, let's add an event to the shoot animation to tell enemy2 shoot script when to shoot a damage verb. Let's go find the npc2 mesh file. Select npc2 shoot animation. Then go to frame 40. And add a new event. Name the event shootTheDamageVerb. Note that the name matches with the new function we just created in MT2 shoot script. Don't forget to hit apply to save. We are going to disable the enemy1 GameObject in the scene for now. Then hit play to test. There we go. It works. In this lecture, we're going to be fine-tuning enemy2's shooting behavior. First, we want enemy2 to start shooting when it's far from the player. After all, this is a ranged attack. We are going to start by selecting the enemy2 GameObject, then expanding the NavMesh agent component in the inspector. Let's increase shooting distance to 6. This means our enemy2 will stop and start shooting when it is 6 units away from the player. Next, we want enemy2 to keep rotating to the player while it is conceiving of the attack. Let's open up our character script and scroll all the way down to the bottom. Let's create a new public function here called rotateToTarget. Within the function, let's first make sure this character is not dead. Then let's rotate this character to its target along the up axis. Then we're going to go to our enemy2 shoot script. We're going to be calling the function we just wrote from within this script. Let's declare a variable of the type character to hold a reference to the character script. Then we want to get and store the character script in a wake function. The last thing to do is to update enemy2's rotation within update by calling rotateToTarget on the character script. Let's go back to Unity and test. Here we go. The enemy2 starts shooting at a farther range and keeps facing the player while doing so. One more thing that I want to briefly mention is that the player can slash the damage verb. This is not an intended design, but I'll just keep it since it's not a bad idea.
Since we have finished our player and enemies, we are going to be creating the spawner group over the next few lectures. First, let's turn our enemies into prefabs so we can spawn them in runtime. Let's go to Game, Prefab folder. Drag enemy 1 and enemy 2 into the folder to make them prefabs. Now we can delete the enemies in the scene. Next, let's create a new empty game object and name it spawner. Reset its transform and add a box collider. We are going to set the box collider to its trigger and set the x-axis and z-axis of the size to 5. When the player enters this box collider, we want to spawn some enemies. Next, we need to specify the spots where we want the enemies to spawn at. Let's create a new game object and call it spawn point. Reset its transform and move it away from the origin point of the scene. Then add a label to help us visualize it in the scene. Now, we are going to create a root game object for both spawner and spawn point. This helps us manage these game objects in the scene. We're going to select spawner and spawn point. Right-click and select Create Empty Parent. Rename the parent game object to spawn group. In this lecture, we're going to be writing the scripts for spawn point and spawner. First, let's go to Game, Script, and create 2 C# scripts here. Name them spawner and spawn point. Let's start with spawn point script first. Get rid of start and update. This script is going to be the simplest script we have ever written. It only contains 1 line of code. Let's declare a variable of type GameObject and call it empty to spawn. It is to hold a reference to an enemy prefab. Next, let's jump to our spawn script. Again, we don't need start and update here. We need 2 variables here. The first one is a private list of game objects. It is going to contain all the spawn point game objects in the same spawn group. Let's call it spawn point list. The second one is a private bool. It stores whether this spawner has spawned some enemies. In a wake function, we're going to get all the spawn point game objects under the same spawn group and store them in our list. We say transform.parent, which is the parent game object of this spawner, which should be the spawn group game object. Then we call getComponentInChildren on it. This is going to return an array that contains all the spawn point scripts in the children game objects under the spawn group game object. Because the return value is an array, we're going to store it in a temp variable called spawnPointArray. Then we can convert the array into a list and store it in spawnPointList. Next, let's create a function called spawnCharacter. We want to check if this spawner has spawned anything before we spawn any new enemies. If has spawned is true, let's just return here. Under the if block, let's write the code that spawns some enemies. First, we want to set has spawned to true. Then we use a for each loop to go through all the spawn point scripts in our list. We want to check if the current spawn point script holds a reference to an enemy prefab. If it does, let's initiate a new enemy from the prefab. At the current spawn point's position, and store the return value, which is the newly spawned enemy game object, in a variable. The last thing to do is spawn the enemies when the player enters the box collider trigger. We can do this in onTriggerEnter. Let's check if the other game object is the player by checking its tag. Then we're going to call spawnCharacter. In this lecture, we're going to finish the spawn group game object.
First, let's select the spawn game object under spawn group and drag the spawn script to it. Next, let's move the spawn game object a little bit away. Then, let's select the spawn point game object and drag spawn point script to it. Go to Game Prefab folder. Drag enemy1 prefab to enemy to spawn parameter slot in the script. Let's hit play to test. Great, an enemy is spawned when the player enters the box collider. You'll notice that we cannot see the box collider in the game scene when the spawner game object is not selected. This is going to make it hard for us to design and test the game. It's better if we can see the spawn collider all the time. Let's make the box collider visible. Open up the spawner script. At the top, let's add a variable to hold the reference to the box collider. Then at the bottom, let's use onDrawGizmos, which is a Unity built-in function that we used before when we needed to visualize the contact point for us to place the player's attack VFX on the enemy. In the function, let's set the gizmo's color to red. Then use drawWhereCube in gizmos, passing the center position of the cube and the size. Okay, let's jump back to Unity. Drag the spawner game object to the spawner script. Now, we can always see the box collider of the spawner. In this lecture, we're going to be creating the spawn material VFX for the enemies. First, let's go check some properties we are going to tweak via script in the materials shader. Go to Game Prefab to find the enemy1 prefab. We can see its material on the right side. Let's turn on Enable Damage, then adjust Dissolve Height. These two properties are what we are going to change in the code. Let's turn off Enable Damage, and go to the shader to check the property names. The names are _enable_dissolve and _dissolve_height. Okay, now we can exit the enemy1 prefab by clicking the small arrow at the top left corner in the hierarchy window. Let's open our character script and write some code. We're going to scroll all the way down to the bottom and create an IEnumerator function here. Let's call it materialAppear. We're going to declare 5 flow variables. The first one is dissolve time duration. Let's initialize it with the same duration as spawn duration. The second is current dissolve time, which keeps track of how long the dissolve VFX has been taking place. The third and fourth are the start and end values for dissolve height. The last one is a variable that stores the current value for dissolve height. Before we tweak the values, we want to set _enableDissolve property to 1, which means to turn it on. Then let's update the material property block. Next, let's write a while loop. The condition of the loop is when current dissolve time is less than dissolve time duration. Then, let's add time time to current dissolve time. And calculate the new value for dissolve height using mathf $. Let's set _dissolve_height property in the material property block to the new value we just got. Then update the material property block. The last thing is to tell Unity to wait for 1 frame until the next loop. Under the while loop, we want to turn off _enableDissolve property, then update the material property block. Alright, let's go to switch state to function to activate the material appear function when the enemy is spawned. Let's go to case character.spawn in the entering a new state switch block and add start coroutine material appear. That's it. Let's go back to Unity. I want to remind you again, please don't forget to save your script and Unity project before testing, because we just wrote a while loop which could potentially crash Unity if anything goes wrong. There we go. The material VFX looks amazing. In this lecture, we're going to be adding a new spawn state to the enemies so that when they are spawned, they will stay right there for a brief moment and show the spawn material effect. First, let's open up our character script and add a new state called spawn in character state enum declaration. Next, let's add two variables. The first one is a public float called spawn duration, which defines how long the enemy is going to stay in spawn state. The second one is a private variable of type float called current spawn time. It helps us keep track of how long the enemy has been staying in spawn state. Let's jump to switch state to function. First, let's add a new case for spawn state in the entering a new state switch block. We want to set is invincible to true because we don't want the player to be able to damage the enemy while it's being spawned. Next, let's set current spawn time to spawn duration, which is 2 seconds. Then break. Okay, let's go back up and add a new case for spawn state in the exiting the current state switch block. We want to check if we are exiting spawn state. If we are, we want to set is invincible to false. Then break. Now, let's go to fix update function. Let's add a new case for spawn state in the switch block. We want to update the current spawn time by subtracting time.time from it. So when it becomes 0 or less than 0, we want to exit spawn state and enter normal state. That's it. Let's jump back to Unity and test. Let's pause the game when the enemy is just spawned. Select the enemy. We can see current state on the right side is spawn. Two seconds later, it becomes normal and the enemy starts walking toward the player. Perfect. Now let's work on some game mechanisms. We want to set up a gate to block the stairs, and we want the gate to unlock when all the enemies are defeated. Let's move the scene view to the stairs and go to Project Little Adventure, Mesh Asset, Environment, Prefab folder. Find a prefab called Gate Wide and drag it into the game scene. Place it at the foot of the stairs. Turn on snapping in progress. Then slightly move the gate to make it align with the stairs. This prefab is only the visual part of the gate. Let's create a parent game object for it. Right-click on the Gate Wide prefab in the hierarchy and select Create Empty Parent. Name it Gate. Select the prefab and rename it to Visual. Select the Gate Game object. Let's add a box collider component to it so it can block the player. Set the collider's center X to -1.75 and size to 3.541.
Now we can see the collider completely covers the visual. Let's hit play to test. Great, our player cannot go up the stairs anymore. In this lecture, we're going to be writing the gate script that triggers the gate to open. Let's go to Game Script and create a new C# script. Let's call it Gate. Open the script and get rid of start and update functions. Let's declare 4 variables here. The first one is a reference to the visual game object. It's a public variable of the type of game object. Let's call it gateVisual. The second one is a private reference to the box collider component. Let's call it _gateCollider. The third one is a public float called openDuration, which defines how long it takes for the gate to open. Let's initialize it with a value of 2. The last one is a public float called openTargetY, which defines the target position of the y-axis for the gate. Let's set it to -1.5f. Don't forget to get and store the collider component in a wake function. Next, let's write the function that opens the gate. The function needs to be a coroutine function, which means we need to put the keyword IEnumerator in front of it. Let's call it openGateAnimation. First, we need 3 variables here. We need a float to store the current duration of the opening process. Let's set it to 0. Then a variable of the type vector3 to store the start position of the gate. Let's call it startPOS and set it to the visual prefabs position. The last variable is also a vector3, which stores the target position we want to move our gate. Let's call it targetPOS and set it to startPOS plus the result of the up axis times openTargetY. Now let's write a while loop and move the gate visual in it. The condition is when current open duration is less than open duration. We're going to repeat the while loop and keep moving the gate. In the while loop, let's add time.delta to current open duration. Then we move the gate visual using vector3.lerp. Last, we say yield return null, which tells the while loop to wait for the next frame. Okay, when the while loop is finished, which means the gate is opened, we want to disable the collider so the player can go on the stairs. Let's jump back to Unity. Select the gate game object and drag the gate script to it. Don't forget to assign the visual game object to the script. In this lecture, we're going to be updating our spawner script so it can unlock the gate when all the spawned enemies are eliminated. Let's find and open up the spawner script. First, we want to keep track of our spawned enemies, so we'll know it when they're all eliminated by the player. Let's add a new private list of character scripts. We are going to call it spawned character. Don't forget to init the list in a wake function. Okay, go to spawn character function. Right after we spawn an enemy, we want to store it in the list. Remember, the list can only contain values of character script. So let's get the character script from the new enemy. Now let's check the state of all the enemies in the list in update function. But first, we want to check if this spawner has not spawned any enemies. Or if the list contains 0 members.
If any of these conditions are true, we are going to return. So the following code won't be executed. Next, let's declare a new bool variable called all spawned are dead and set it to true for now. Then we check all the members in the list in a for each loop. Remember, the members are of the type of the character script. If any of their character state is not dead, we know the enemies are not all defeated. So we're going to set all spawned are dead to false and immediately break the loop. After that, we want to check if all spawned are dead is still true. If the answer is true, we want to tell the gate to open. Let's pause here and go back up to include the Unity engine.events namespace. Then let's declare a public variable of the type Unity event called onAllSpawnedCharacterEliminated, so that the gate script can listen to this event and do something when this event is invoked. Alright, let's go back to our if block. Let's check if this event is not null, meaning some other script has registered for it. Then we want to invoke the event. There is one more thing to do. We need to clear the list in case the update function is going to keep invoking the event forever. Alright, let's jump to our gate script and add a new function that is going to be called every time the event in spawn script is invoked. It's a public function. Let's call it open. In the function, we just need one line of code. Let's start the open gate process by calling start coroutine open gate animation. That's it. Let's go back to Unity. Select the spawner game object. Now we can see the event we just added to the spawner script. Click the plus to add a listener. Let's drag in the gate game object to the listener slot. Then select open function in the gate script. That's it. Every time this event is invoked, open function in the gate game object is going to be called. Before we test our code, we want to delete one of the spawn points, so we don't have to deal with too many enemies just to see if the gate will open. Great! The gate is open when all the enemies are down. There is just a small problem. We can still see the spikes of the gate on the ground, meaning we didn't move the gate down enough. It should be easy to fix. Just select the gate game object and change the open target Y to -2. Let's also disable one of the remaining spawn points, so we only need to deal with one enemy this time. Here we go. The gate open animation is perfect now. Before we move on to the next lecture, there are still two things to do. First, we want to reuse the gate game object later on. Let's go to Game Prefab and drag the gate game object into the folder to make it a prefab. Second, let's enable the spawn points again. In this lecture, we're going to write the game manager script. First, let's head to Game Script and create a new script here. We're going to call it Game Manager. Let's open the script and get rid of start function, but we're going to keep update function. In the top, let's declare two variables. First, in order to keep track of the player state to determine when the game is over or finished, we need a variable of type character to hold reference to the character script in the player. We're going to call it player character. Second, we need a bool called game is over for the state of the game.
Let's get and store the character script from the player game object in a wake function. Next, let's create two functions, game over and game is finished. For now, we're just going to print out some messages from within them to test. In update, we want to check if the game is not over yet. If it is over, we want to return right here so the following code won't be executed. Next, if the game is not over, we want to check the player state. If the player is dead, we want to set game is over to true and call game over. Alright, let's jump back to Unity and create a new empty game object. Let's call it GM. Drag the game manager script to it. Next, let's expand the spawn group game object. Select spawner under it, then add a new listener to on all spawned character eliminated. Drag the GM game object to the slot and select game is finished in the game manager script. Let's disable a spawn point and hit play to test. Okay, when the only enemy is down, you can see the text message, game is finished, in the console window. Let's stop and restart the game. This time, we want to make sure game over is triggered when the player is defeated. There we go. You can see in the console window, it says game over. Let's stop the game. Re-enable the spawn point that we disabled before. Let's create a new empty game object called game and move some game objects under it to keep the hierarchy better organized. In this lecture, we're going to be adding more enemies and gates to our game. We're going to start by moving our player game object along the z-axis from 0 to 7.5. Then let's set the y-axis rotation to 0 to make it face the right direction. Next, let's expand the spawn group. Select the spawner game object under it, then move it along the z-axis to 4.5. Then we're going to make the trigger wider by increasing its size of the x-axis to 18.77. We also want to move the spawn point a little bit. Then delete the second spawn point because we don't want the player to face two enemies since this is only its first fight. We're also going to move the gate game object into the spawn group. Next, let's select the spawn group and Ctrl-D to duplicate it for our next battle zone. Rename the new spawn group to spawn group 2 and the old one to spawn group 1. Move the GM game object up so it won't be staying between spawn groups. Okay, let's move spawn group 2 to our next stage. Remember to keep the snap option on. It helps us snap the game objects to the grid. Let's move the gate game object to the base of the stairs on the left side. Ctrl-D to duplicate the gate game object and move it to the right side in front of the right stairs.
move the gate 1 game object up to next to the gate game object. Select the spawner game object and move it to -2, 0, -0.5. Move the spawn point game object to -6, 0, 5. Ctrl D to duplicate it and move it to -1.5, 0, 13.5. Select the first spawn point game object, then double-click on the enemy 1 in the spawn point script component. This is going to lead us to the prefab folder. From here, let's drag enemy 2 prefab to replace enemy 1 prefab so that this spawn point is going to spawn an enemy 2. Let's select the spawner game object. We can see that it only tells one gate to open at this moment. Let's add another listener and drag the gate 1 game object to the slot. Select gate open in the gate script. Let's rename the gate game objects and spawn point game objects. Alright, we need one more spawn group for a final stage. Let's select spawn group 2 and Ctrl D to duplicate it. Rename the new one to spawn group 3 and move it to -3.5, 6, 49. We don't need these two gates anymore. Let's just delete them. Select the spawner game object and move it to -11, 0, 1. Then set the size of its box slider to 5.83, 1, 18.4. Let's select spawn point 1 game object and move it to -22.5, 0, 2. Then select spawn point 2 game object and move it to -31.5, 0, 7. Ctrl D to duplicate it and move the new one to -36.5, 0, -2. Then rename the new one to spawn point 3. Last step. Select the spawn game object, delete one of the two missing listeners. Then drag the GM game object to the only listener slot and select Game Manager, Game is finished. By doing this, we are telling the Game Manager to finish the game when all enemies on stage 3 are defeated. Alright, let's hit play to test. There we go. The gate opens after we take down the first enemy. Alright, both gates are open when the enemies on stage 2 are defeated. Finally, we see game is finished in the bottom left corner when we defeat all the enemies on stage 3. In this lecture, we're going to be updating the spawn point and spawner scripts to give us the ability to control the spawn direction of the enemies. We can see our enemies always spawn facing the same direction. It would be better if we could control the facing direction freely. Before we write the code to control the spawn facing direction, let's add some visualization to the spawn point first, so that we can see their location and their facing direction in the game scene. Let's add to the spawn point script. We're going to draw a cube at the spawn point game object and a line along its facing direction. Let's write the code in onDraw Gizmos, which is a Unity built-in function to help us draw stuff in the editor. We're going to start by setting the color to green. Then, let's find out the center position for the line and the cube. Now, we can draw a cube at the center and set its size to 1 unit. Let's also draw a line from the center to the game object's facing direction. Let's jump back to Unity. Even without the spawn point game object being selected, we can see a green cube that represents the game object and a green line along its facing direction. Let's rotate it along the y-axis by 180 degrees and move it to 0, 0, 0. Also, move the base model to the spawn point game object. Now, let's go to our spawner script, find the line that spawns the new enemy, and change quaternion.identity to point.transform.rotation, which means the enemy will be spawned facing the spawn point's forward direction. Let's jump back to Unity. There we go, the enemy now faces the spawn point's forward direction. Now, let's go over all of the spawn points and update their location and rotation. In this lecture, we're going to be setting up a coin game object that the player can pick up later. First, let's go to Project Little Adventure, Mesh Asset, Environment, Prefab. Find the coin prefab and drag it into the game scene. Let's expand the prefab and check out its structure. We can see there is a visual game object under the root game object, then the mesh game object, which is the model under the visual game object. In this lecture, we're going to be writing a script that keeps rotating the coin. Let's go to Game, Script, and create a new C# script. We're going to call it Rotator. Open the script up and get rid of start function. Let's declare a float called speed and initialize it with a value of 80f. In update function, we use transform.rotate to rotate the game object every frame. The first parameter is the rotation to apply in Euler angles. We only want the coin to rotate along the y-axis, so let's create a new vector 3 and leave x and z to 0. For y, we put in speed times time. For the second parameter, we're just going to pass in space.world. Let's jump back to Unity. Select the visual game object under the coin game object, and drag the rotator script to it. Hit play to test. We got it. In this lecture, we're going to be adding something to make the coin collectible. First, let's select the coin game object and add a sphere collider to it. Set the y-axis of the center to 0.5 and check its trigger. Then let's drag the pickup script to it and change the type to coin. Let's double-click the script to open it up. We want to have a VFX playing whenever this game object is picked up. At the top, let's declare a public variable of the type particle system that holds a reference to the VFX prefab. Let's call it collected VFX. Then in onTriggerInter function, we want to check if collected VFX is not null, meaning we have a VFX prefab assigned. Then we're going to initiate a new VFX at the pickup's location. Let's go back to Unity. Go to Project Little Adventure VFX Prefab. Drag in the particle collected prefab to the collected VFX slot in the script. Alright, before we test our code, let's select the player game object. Then hit play to test. We can see after the player picked up the coin value in the character script increased from 0 to 20. In this lecture, we're going to be adding more coins and gates to the game. Let's make sure all the changes from the last lecture on the coin prefab in the scene are applied. Then we can delete it. Let's move the view to the hidden alley on the right side of stage 1. Drag a coin prefab from Game Prefab folder into the alley. Ctrl D to duplicate the coin and reposition it 3 times. Let's also place some coins in the hidden corners. Alright, let's create a new empty game object called coins to hold all the coin game object in the scene. Select the coin game objects and move them under coins. Also, move the coin game objects at the top into coins. Collapse the coins game object and move it into the game object. Now let's add a new gate to block the player from entering the hidden alley. Select and Ctrl D to duplicate the gate on the first stage, and move it to the entrance of the alley. Let's rename it to Gate 2 and sort it out in the hierarchy. We're going to select the spawner game object and add Gate 2 as the listener. Select Gate Open function, so that when the player takes down the enemy, Gate 2 will open as well. Let's hit play to test. There we go. Now we can enter the alley and collect coins. By the way, the coin behind the stairs is not visible. Let's move it out a little bit.
In this lecture, we are going to be setting up the game UI and going through everything I have created for you. First, let's go to Project Little Adventure, Prefab, UI. Drag Game Canvas Prefab into the hierarchy. You are going to see this window if you are doing this for the first time. This is a setup window for TextMesh Pro, which is a high visual quality text solution that comes with Unity. Because I used TextMesh in the UI prefabs, the window shows up and asks us to import TextMesh Pro Essentials. Let's click Import TMP Essentials and wait for the process to finish. Now we can close the window. Let's expand the game canvas. We can see 4 UI game objects under it. Only game UI is visible. The rest 3 are invisible for now. Game UI contains the player's health bar and coin count. The whole UI is going to fit the size of the screen dynamically. Let's expand Game. Select Health panel and change the scene view to 2D. This panel is made from a UI slider bar. I just changed the images and disable the handle game object. Next, let's select and expand Coin panel. We can see that it contains a text game object and an image game object. That's everything about Game UI. Let's disable it for now and enable Pause UI. Expand Pause UI. We can see 3 buttons. These buttons are all derived from a button prefab. Hit the select button at the top of the inspector. It will lead us to the button prefab in the folder. I placed this button prefab under the panel game object 3 times and changed the text in them. Now let's disable Pause UI and enable Game Over UI. Game Over UI contains 2 buttons. One restarts the game. The other brings us back to the main menu. Last but not least, we have Game is Finished UI with 2 buttons in it. Let's disable Game is Finished UI and enable Game UI again. Before we start working on our UI, let's select the Game Canvas Prefab and right-click. Then select Prefab, Unpack. This is going to unpack the Game Canvas Prefab into a normal game object, so that any changes we are going to do to it are not going to affect the prefab in the folder. In this lecture, we are going to be writing the Game UI Manager script that updates the health bar and coin text. Let's head to Game, Script, and create a C# script here. Let's call it Game UI Manager. Let's expand the Game Canvas game object and check the components we are going to be updating in the Game UI Manager script. The first one is the slider component in the health slider game object. This component controls the player's health bar. The second one is the TextMesh Pro component in the coin text game object. We're going to be updating the text that shows how many coins the player has collected. Alright, let's open up our Game UI Manager script. Let's get rid of the start function. We're going to include TM Pro and Unity Engine.UI namespace at the top. Then we're going to declare 2 variables. The first one is a public variable of the type GameManager. Let's call it GM. The second one is a public variable of the type tmpro.textmeshPro.uGUI. Let's call it CoinText. It's going to hold a reference to the text component in the CoinText game object. The last one is a public variable of the type slider called healthSlider. It is going to hold a reference to the slider component in the healthSlider game object. Now let's go to the Game Manager script and change the private variable playerCharacter to public so that we can access it from our Game UI Manager script later on. because the slider component for the player's health bar only receives a value from 0 to 1. So we need to go to our health script to add a new value that maps the current health to a value from 0 to 1. At the top, let's declare a public float called current health percentage. We're going to add a get method to this variable. Let's calculate the 0 to 1 value in the get block and return it so that every time we access current health percentage, we're going to get the calculated value based on current health and max health. Alright, let's jump back to the GameUI Manager script. In update function, we want to set health slider.value to current health percentage in the player's health script. Then we want to set coinText.text to the player's coin value. CoinText.text is a string type, and the coin value in the character script is int, so we need to convert the int type value to a string type value. Let's get back to Unity. Select the game canvas game object and drag the GameUI Manager script to it. Then drag in the GM game object, the health slider game object, and the coinText game object to the parameter slot. Let's hit play to test. There we go. The health bar decreases when the player gets hurt. The coin text also increases when the player collects coins. In this lecture, we're going to create a simple state machine for the GameUI to switch between different UIs. Let's open up our GameUI Manager script. At the top, we're going to declare a new enumeration called GameUI state. Then we're going to have 4 members for 4 states of the UI. Gameplay, pause, game over, and game is finished. We want the correlated UI to show up when we enter a UI state. We also need a variable of the type GameUI state to store the current state of the UI. Let's call it current state. Next, let's declare 3 variables of the type GameObject to reference to the UI GameObjects. They are UI pause, UI game over, and UI game is finished, and they're all public. Alright, let's scroll down to the bottom to create a new function called switch UI state. It takes a GameUI state type parameter called state. We call this function whenever we want the UI to switch to a new state, and it is going to display the correlated UI and hide the rest. First, we want to hide all the UI game objects. Next, let's make sure the game is not stopped by setting time.timescale to 1, in case the last state had made the game stop. Then, we use the switch loop on the parameter state to determine which UI game object to show. Let's check if the parameter is gameplay state. Then we don't want to do anything, just break, because we don't need to display any UI when in gameplay state. Next, when in pause state, we want to stop the game by setting time.timescale to 0. Then show the pause UI by saying UIPause.setActive true. Don't forget to break. The third stage is game over.
We want to show the game over UI by saying UI gameObject.setActive true. Then break. The last state is game is finished. We want to show the game is finished UI by saying UI game is finished.setActive true. Then break as well. There is one more thing to do. We need to update current state to the state parameter. We also want to create a toggle pass UI function to help us toggle the pass UI easily. Let's check if the current state is gameplay. If it is, we want to switch to pass state. On the other hand, if the current state is pause, we want to switch back to gameplay. Later, we can use this function to show or hide the pause UI. In this lecture, we're going to be writing the code that allows the player to pause or resume the game with the ESC key. We want to do this in our game manager instead of game UI manager. Whereas game UI manager is just a controller of the UI. It should not be able to pause or resume the game. Let's go to our game manager script. Declare a public variable of the type game UI manager at the top, and call it game UI manager. In update function, we check if the ESC key is pressed. Then call gameUIManager.togglePause. Let's jump back to Unity. First, select the game canvas game object. We can see we have not assigned the UI game objects to the game UI manager script we wrote in the last lecture. Let's do it now. Drag in pause. Game over. And game is finished to the parameter slots. Then let's select the GM game object and drag in the game canvas game object to the game UI manager slot. We can leave the game controller slot empty here since we are going to get it in a wake function at runtime. Okay, let's hit play to test. Press ESC to pause the game, then press ESC again to resume. Great, it worked perfectly. Note that the buttons are not responsible yet. Let's fix this in the next lecture. In this lecture, we're going to be adding an event system to make these buttons responsible. Let's stop the game. Right-click in the empty space in the hierarchy and select UI panel. This is going to add a new empty canvas and an event system to the hierarchy. We don't need the new empty canvas, let's just select and delete it. The event system is what we need. It's essential for any UI to work. With it in the scene, all the UI game objects can receive input, like the movement of the cursor, click, and keyboard input. Now let's hit play to test. See, the buttons respond when the cursor hovers over them. We have not told these buttons what to do yet. Let's do it in the next lecture. In this lecture, we're going to be writing some code to make the resume button and the restart button work. First, let's check out all the buttons we have here. We have resume, main menu, and restart in pause UI. Then restart and main menu in game over UI. In game is finished UI, we have restart and main menu. Let's go to the game UI manager script and add two functions. Button underscore main menu and button underscore restart, they're both public. These functions are going to be called when the player clicks the buttons, but we are not going to cover the actual function in them. Because the only mission for the Game UI Manager script is to receive the player's actions, not to handle the game mechanism, such as returning to the main menu or restarting the game level. So let's go to the Game Manager script and add another two functions that actually handle the game mechanisms. Let's add two functions at the bottom, return to the main menu function and restart function. We're going to include Unity engine.sceneManagement namespace at the top, so we can load the main menu scene or reload the current game scene. In restart function, let's write the code that tells Unity to reload the current game scene so that the game seems like it has restarted. We use sceneManager.loadScene to do so and pass in the name of the current scene, which we can get using sceneManager.getActiveScene.name. Next, let's go back to the Game UI Manager script. In button restart function, let's call restart on GM. Alright, let's go back to Unity. Enable pause game object and select button_resume. In the inspector on the right side, scroll down to find the button component. See, there is an empty listener slot under the onClick function. Let's drag in the game canvas game object to it and select Game UI Manager, toggle pause UI. By doing this, toggle pause UI function is going to be called whenever the player clicks this button. Next, select button_main menu, drag in the game canvas game object to the empty listener slot. And select Game UI Manager. Button_main menu function. Last but not least, let's start button_restart. Drag in the game canvas game object to the empty listener slot and select Game UI Manager. Button_restart function. Next, repeat our last steps to the buttons in Game Over and Game is Finished game objects. Just be aware and go with the functions that matches the buttons. When it's all done, let's disable the UI game objects and hit play to test. Press ESC to pause the game, then let's hit resume button. Great, it works. Then let's pause the game again and hit restart button. Something is wrong this time, the game just freezes. Okay, let's stop the game and fix the problem. Turns out, Unity needs us to specify the scenes that we are going to load and reload in the game. Otherwise, the scenes won't load or reload even though we have written the code right. Let's go to File, Build Settings. Hit Add Open Scenes at the top. This is going to add the currently opened scene to the build list. Let's close the window and hit play to test again. Okay, it still doesn't work. Why? Let's check our game manager script. It seems like the game is frozen when in pause UI, and we didn't unfreeze it when we reload the scene. Let's switch the UI state back to gameplay in start function. So every time this scene is loading, we are going to switch to gameplay UI state. Therefore, the game will unfreeze automatically. Let's go back to Unity and test. There we go. This time, the restart button works. So far, we have been working on the game scene, but we haven't created the main menu scene. Let's do it in this lecture. Select File, New Scene, select Empty, then hit Create. Go to the Game folder, then type in Main Menu for the name. Hit Save. Let's add this scene to the scenes in the build list. Go to File, Build Settings. Hit Add Open Scenes. We can see the main menu scene has been added to the list. Remember, a Unity game always starts with the first scene in this list. We want our game to start with the main menu scene, so let's move it up to the top. Alright, now we can close the window. Let's open our game scene and go to the Game Manager script. In return to main menu function, we are going to unfreeze the game by setting time.timescale to 1. Then we can load the main menu scene by saying scenemanager.loadScene. Pass in the string name of the scene, which is main menu. Let's go to the Game UI Manager script in button_main menu function. We're gonna call return to the main menu function on GM. Alright, let's go back to Unity and test. As we click the restart button, it says no cameras rendering. I know it doesn't seem like it, but this means main menu scene has been successfully loaded because the main menu scene is completely empty for now, not even with a camera in it, so we have the warning text on the screen. We are going to set up the main menu scene in the next few lectures. In this lecture, we're going to be working on the game over and game is finished UI. Previously, we just displayed messages in the console using debug.log function when the game was over or finished. Since we have the UI now, let's display the UI instead. First, let's add a new function called showGameOverUI in our Game UI Manager script. Let's switch UI state to GameOver init. The UI will show up because we've handled that in switch UI state function. Then we need another public function called showGameIsFinishedUI. Let's switch UI state to GameIsFinishedInit. Let's jump to the Game Manager script. See debug.log in GameOver function and GameIsFinished function. Let's replace them with the actual functions that display the UI. Let's say GameUI_manager.showGameOverUI in GameOver. And GameUI_manager.GameIsFinished in GameIsFinished function. Alright, let's jump back to Unity. There we go. The Game Over UI shows up when the player's health is down to 0. We can hit Restart to reset the game. Alright, let's stop the game here and test the Game is Over UI. We want to be able to test the game quickly, so let's make the spawn group 1 tell our GM to finish the game, so that the game would be finished when the only enemy on stage 1 is defeated. There we go. The game is finished now. Let's hit main menu button to test. Okay, the main menu scene is loaded, even though it still says no cameras rendering like before. Let's stop the game and don't forget to remove the GM from the listener slot. In this lecture, we're going to be setting up the main menu scene, so we would not be seeing that no cameras rendering message anymore. First, let's open up the main menu scene in the game folder. Next, let's go to Project Little Adventure, Prefab, Main Menu. Drag main game level prefab into the hierarchy. Now we can see the visual for the main menu scene. The environment lighting and color from the default scene settings don't fit our visual. Let's fix it. Go to Window, Rendering, Lighting. See the default skybox under Environment tab? That's the skybox material we are about to replace. Go to Project Little Adventure, Settings. Drag in main menu skybox to default skybox to replace it. Now let's place the UI game object. Go to Project Little Adventure, Prefab, UI. Drag main menu canvas prefab from the folder to the hierarchy. Remember that for the UI to work, we need to add an event system. Right-click in the empty space and select UI, Canvas. Delete the canvas game object we just added. Just keep the event system game object. Now let's check out what we have in the main menu canvas game object. Set the game scene to 2D. We can see that the main menu canvas consists of a title image and a panel that contains two buttons, Start and Quit. In this lecture, we are going to be writing the main menu manager script. Let's go to Game, Script, and create a new C# script. Let's name it main menu UI underscore manager. Open it up and get rid of Start and Update. At the top, let's include Unity Engine.scene management namespace and Unity Editor namespace. Let's create two functions for the two buttons in the main menu UI. The first one is button start. When the player clicks the start button, we want to load the game scene. So let's say scene-manager.load scene. Game scene. The second function is button underscore quit. If the player clicks the quit button, we want the whole game program to stop. But if we just click the quit button when the game runs in the Unity editor, we just want to stop the game and go back to the editor. So let's say hash if Unity underscore editor. Then we want the editor to stop playing. Then hashtag and if. Hashtag if and hashtag and if are what are called directives. The program will check if the game is running on the selected platform. Like if the game is running in Unity editor in this case, then run the code in between. Outside the directives, let's say application.quit. This line of code will run when the game is standalone and shut the game down. Alright, let's jump back to Unity. And drag main menu UI underscore manage script to it. Then select button underscore start. And add main menu UI underscore manager dot button underscore start to onClick event. Next, select button underscore quit. And add main menu UI underscore manager dot button underscore quit to onClick event. Great, the game scene is loaded when we hit start button. Let's go back to the main menu. Then click quit button. There we go. The game stops playing in the editor. In the next few lectures, we are going to be making some small improvements to fine-tune our game. We can see here that while the player keeps sliding forward little by little when it keeps attacking an enemy, it will move through the enemy eventually. To fix it, let's push the enemy back a little bit when it gets hurt. Let's open up the character script. Go to Apply Damage function. Under the if block at the bottom, we want to add an else block. Let's say if this is not a player, we want to add impact. The intensity of the impact is 2.5 F. Alright, let's go to Fixed Update function. Select the code under case character state dot being hit and cut and paste it out of the switch block, right above the if is player block. And add an else block under the if is player block. Let's check if current state is not normal. Then we want to move the enemy and reset underscore movement velocity to 0. That's it. Let's hit play to test. Now the enemy is pushed back a little bit. Perfect. Sometimes it's a little hard for us to see the player and the enemy when they are behind something that blocks our sight. In this lecture, we are going to be adding a wall material dither effect so that we can see them behind the wall. I have included the effect in the player and enemy's material, but it only works with game object in a certain layer. So let's select the visual game object under the player, then change its layer to player. Select yes. We also need to change the visual game objects in our enemies. Let's go to Game, Prefab. Double-click the Enemy 1 prefab to open it up. Then select the visual game object and change its layer from default to enemy. Select Yes, Change Children. Then do the same thing to the Enemy 2 prefab. Open it and change the layer of the visual game object to enemy. Select Yes, Change Children. Now let's go back to the game scene and test. There we go. Now we can see the characters through the wall. There is a small problem though. Let me show you. When the enemy is dead, we can see a part of his feet are under the ground. This triggers the dither effect. The solution is simple. We just need to change the layer of the mesh game object back to default. Then the dither effect will disappear. Alright, let's jump to our character script. Go to Switch State to function. Under case character.dead. Let's add an if block above break. The condition is its player is not true, which means this is an enemy. We want to get the skinned mesh renderer component from the children. Then store it in a variable called mesh. Then we're going to set the layer of the mesh to 0, which is the default layer. Let's go back to Unity to test. Now, after the enemy disappears, we don't see the dither effect. If we select the NPC 1 mesh game object, Now we can see its layer is default. I believe you've noticed that when we left-click to attack, the player only attacks toward its facing direction. I think it could be more convenient if the player rotates to the direction of the cursor before attacking. Rotating the player should be the easiest part, but managing to get the direction from the player to the cursor requires some extra work. Let's go find our player game object, right-click on it. Select 3D object, plane. Rename the new plane game object to cursor test plane. And increase its scale to 5, 1, 5. Then we're going to disable its mesh render component so we don't see it in the game. If we click on the mesh collider component, we can see the plane is still there in the scene, following the player since it's a child of the player game object. Next, in the layer dropdown, select Add Layer. Add User Layer 10. Tap in Cursor Test. Now the new layer has been added, but we haven't assigned a layer of the plane to it yet. Select the Cursor Test Plane Game object in the hierarchy again. This will bring us back to its inspector. Now we can change its layer to Cursor Test. Alright, we have set up everything. Let me explain what we are going to do. First, we're going to cast a ray from the cursor to hit this plane. Then we'll get the hit position and use it to figure out the direction from the player to the hit position. Once we have the direction, we can rotate the player to it. That's it. Let's go to our character script. Scroll all the way down to the bottom. Before we do the actual work, we want to test if we get the hit position correctly. Let's use the Unity built-in function onDrawGizmos again. First, we declare a ray type called ray. It's going to be the ray sent down from the mouse position. Let's generate the ray by saying camera.main.screenPointToRay input.mousePosition. Next, we need a variable of the type rayCastHit to store the hit result. Let's call it hitResult. Alright, now we can cast the ray and test the result. Let's put the rayCast code in an if statement. Then we're going to use physics.rayCast. The first parameter is the ray we just generated. The second one is the result. We put the keyword out in front of it. So the rayCast function will write out the result value to the variable result. The third one is the distance of the ray. Let's set it to 1000. The last one is the layer mask. We only want the ray to interact with the plane. So we set the layer mask to the plane's layer mask, which is cursor test. In the if block, let's declare a vector3 called cursorPOS to store the hit point. Set the gizmo color to red. Then draw a weird sphere at the hit point with a radius of 1. Alright, let's jump back to Unity. There is one more thing to check. Let's select the player game object and check the inspector window on the right side. In Unity, you have to make sure the script component that you roll onDrawGizmos in is expanded in the inspector. If the component is collapsed like what we have here, the code in onDrawGizmos is not going to work. So let's click the little arrow in front of it to expand it. Then let's hit play to test. There we go. We can see the red sphere in the game scene following our cursor on the plane. Let's stop the game and go back to our character script. Above onDrawGizmos function, let's create a new private function called rotateToCursor. Copy all the code in onDrawGizmos and paste it here. Delete the last two lines that draw the sphere. Instead, let's rotate the character toward the cursor POS. Let's use quaternion.lookRotation to find out the new rotation. We're going to subtract the current character's position from cursor POS to get the new forward direction. then pass in vector3.up as the upward direction. That's it. Let's go to calculate player movement function. At the bottom, let's call rotate to cursor function. We put a code here to help us test if the player will rotate to our cursor, but we're gonna delete this line later. Alright, let's jump back to Unity. Hit play to test. Hover the cursor in the game view. You can see now the player keeps rotating to our cursor, which means our code works. Let's go back to the code and delete rotate to cursor. Then let's go to switch state to function. Find case character.attacking in switch new state block. Go to the second if is player statement. Add a pair of braces to make a block. Under attack start time equals to time.time. Let's call rotate to cursor function. Next, let's go to fixed update function. Comment out calculate player movement at the bottom of case character state.attacking. That's it. Let's go back to Unity. Hit play to test. Now the player doesn't rotate to the cursor when it's in the idle state, but when we left click to attack, it rotates to the cursor. Alright, this wraps up the fine-tuning section. We have just one last thing to do, build our game and play. In this lecture, we are going to be building our game. After that, you can play with the level and the code to create your version and send it to your friends. Let's go to File, Build Settings. Make sure Main Menu is at the top and Game Scene is right below it. Select PC, Mac, Linux Standalone as the platform. Then hit Player Settings. You can set the project name here. Close the window, then hit Build. It's going to ask you for a folder. Let's create a new folder under our Unity project folder. We're going to call it Build. Hit Select Folder. The building process could take a while depending on the performance of your CPU. After Unity finishes building, let's go to the Build folder. Double-click the exe file to start the game. There you go, you made it. Please enjoy the game and keep playing with the level and the code. I encourage you to create your own version. I can't wait to see what you are going to create with this tutorial. Thanks for watching this tutorial. I hope you enjoy the journey. Please let me know if you need any help.
Thank you for watching. Subscribe now and press the bell icon. Never miss any update.